Yes, hello guys. I hope I am audible. Yes, please confirm. Am I audible and screen is visible? Yes, guys, please confirm. Am I audible and screen is visible to you? Chaliye. Okay. Chaliye. Okay. I'm really sorry for kept you waiting. Actually, I just got stuck in the jam. Okay. Chaliye. No worries. Let us start soon. Correct. So today we'll be starting with the new algorithm, that is support vector machine. Okay, and we have completed guys till random forest, right? We have completed decision tree, and today we'll be starting with support vector machine, right? Chaliye. So guys, just write the topic support vector machine, and I'll start with the basic introduction. What exactly support vector machine is? Okay. Right. So, guys, support vector machine, it is firstly an expansion of logistic regression. Okay. So just write it that it is the updation. Okay. Updation of logistic regression model. Okay. It is an updation of logistic regression model. Okay. So this is basically designed to improve it is basically designed to improve the logistic regression accuracy. Okay, it is designed to improve the logistic regression models accuracy. Okay, it is designed to improve the logistic regression models accuracy. Okay, so it is also suited for binary class target variable. Okay, it is also suited for binary class target variable and majorly used for categorical data. Okay, so it is majorly used for categorical data. Okay, yeah. So Newsbuster, today the class would be of around 3 hours, right? So we'll most probably stop class at 1:30. Okay, so we'll have a break of 15 minutes in between, and we'll stop our class at most probably at 1:30. Okay, चलिए तो अच्छा यहाँ पर as I told you, it is most suited for categorical data, and it creates hyperplane when there are more than one variable to classify the data points. Okay, so here hyperplanes are created. Okay, hyperplanes are created. Hyperplanes are created. Okay, to classify the data. Okay, into more than one classes. Okay, to classify the data. So instead of a sigmoid curve here, what actually is created here, the hyperplanes are created. I'll show you the animation part. The things would get really very clear. Okay, chaliye. And here the points belonging to one class. Okay, points belonging to one class remains on one side of the hyperplane. Okay, remains on one side of the hyperplane. Okay, and the data, okay, and the points or the data and the points belonging to the other class remains on the other side of the next hyperplane. Okay, so guys, you just write all these points. I'll explain one by one everything. Okay, you just give me your 100 minutes. Definitely I'll explain you each and everything. Okay, so yeah, so here the points belonging to one class remains on the one side of the hyperplane, and the points belonging to the other class, okay, other class remains on the other side, okay, of the next hyperplane, right? So this is all about support vector machine. Okay, this is all about support vector machines introduction, right? Up now I'll explain everything. What is hyperplane, why exactly we draw this hyperplane, what are support vectors, everything I would explain you. Okay, so just I'll say that instead of drawing a sigmoid curve, what do? Here we try to fit the hyperplane. Okay, instead of drawing a sigmoid curve, what do? Here we try to fit the hyperplane. Okay, चलिए अब यहाँ पर for binary class task it is majorly preferred. अच्छा, it works well with high dimensional data set. Okay, it works well with a high dimensional data set. Okay, you can just write it, high dimensional data set. It works well with high dimensional data set. Okay, acha, it is robust to overfitting, right? So you can just write it is robust to overfitting. Okay, this is robust to overfitting. So one of the very good points that you could remember, that support vector machine is robust to overfitting and outlier resilience. Okay, there is resilience to outlier. I'll just tell you what is this outlier resilience. Okay, resilience to outliers. So here I hope you have encountered a new word, that is outliers, and very important, highly asked in the interviews. Okay, highly asked in the interviews. So I'll just tell you what exactly outlier is and the difference between outlier and noise. Very important and very interesting. Okay, so I'll just wait for a minute. Please write these points, then let us start with this. Okay, so it will take around 3 hours to complete the entire support vector machine along with the Jupyter file and certain numericals. Okay, now let us see firstly what outliers is. Okay, now for example I'll just explain the difference between outliers and noise. Very important, highly asked in the interviews. Okay, very important, highly asked in the interviews. So what exactly this outlier is, I'll just explain you. Correct. Chaliye, now outlier and noise. Okay, now for example Rohit Sharma, if I just see the Rohit Sharma's the runs scored in different matches. Okay, Rohit's runs scored in all the innings. Okay, in all the innings. I hope you remember I hope you remember the Rohit's maximum score. Rohit's maximum score was what? Was 264 against Sri Lanka. I hope you remember the Rohit maximum scores in all the innings till now he has played was 264 in against Sri Lanka. Okay, now if I try to make a box plot, okay, now what I'm doing is if I try to make a box plot of Rohit Sharma's innings, okay, of Rohit Sharma's inning, don't you think that the majority of the score scored by Rohit Sharma is around where? Is around, if I just try to make a box plot, no, I'll just draw it here. Yeah, I'll just draw it here. The box plot, I'll just draw it here. If I try to make the box plot, okay, yeah, if I just try to make the box plot of Rohit Sharma's score, so this would be the box plot of Rohit Sharma's score that he has scored in total all the innings. Okay, so majorly what is box plot? Box plot tells us this is the median score. Okay, this is the median score. Okay, this is the lowest score. Okay, this is the minimum score. Okay, this is the median score of all the runs, right? Acha, this is what? This is the maximum score. Okay, this is the maximum score of Rohit Sharma's scores that he has scored in all the innings which he have played. So I can consider this maximum. I can consider this maximum as this score is 264 against Sri Lanka. So I can consider maximum score as an outlier. Why? Because the majority of the scores, okay, if I just see the 3/4 of this score, okay, this is what? This is known as the third quartile. Okay, this point is known as the third quartile. So third quartile would be around where? Third quartile would be around where? It would be around at 135 to 140. This would be the range of the third quartile, not more than this. And if I saw the maximum scored by Rohit Sharma, that is 264. So once only he has scored, okay, once only he has scored, but the Q3 is very much down, okay, is very much low as compared to the maximum score. So what is outlier? Outlier are those points that show aberrant behavior, abnormal behavior from okay, of the total of the entire scores, okay, scored in all the innings which he has played. So that is actually that we can get actually through a box plot. Okay, that actually we can get through the box plot. So this is how yeah, so this is how I can treat this maximum score as the outlier, because this is one of the I would say the abnormal scores or aberrant behavior from the normal scores which he makes. Okay, so yeah, yes, what is third quartile? That is the 75% of the score. Okay, the 75% of the score of the total scores in all the innings which he has played. Okay, so that is known as the third quartile, right? So this is what? This is the 75% of the total scores which he has played in all the innings. So that would be around 135 to 140. But this 264 is an aberrant one because only once he has hit it. Okay, so that is why I can consider 264 as an outlier in this scenario. Okay, I can consider 264 as the outlier in this scenario. Okay, this is the median, I mean the 50% of the total scores. Okay, this is median, the 50% of the total scores till now in all the innings which he has played. Okay, this is first quartile, that is 25% runs that he has scored, 25% runs that he has scored, 25% scores that he has played, he has scored in all the innings. Okay, till now. Okay, so that is what is the run. अब जैसे मान लीजिए 50, the median score scored by Rohit Sharma, it may be around I think 75. Okay, the total, I mean the median scores that the Rohit Sharma has played may be around 75 runs, 75 to 80 runs, and the first 25% score may be around 10 to 12 runs. Okay, because he has got out on duck, no? So minimum score would be how much? Minimum score would be 0. Okay, so 0 runs would be the minimum score. Okay, so this is how the outliers are actually treated, right? This is how the outliers are actually treated. And what is noise? Noise in the data. So noise in the data is the deviation from the trend which actually is observed for a short duration or for a long duration of time. Now for example if I just draw a scatter plot, no, between any variable, independent variable x, okay, independent variable x and y. So for example, the trend is increasing, no, for example, the trend is increasing with increasing x, okay, the scores or the y, the is increasing with increasing x, okay. Suddenly I saw that after a certain period of time, the points started decreasing, okay, the x started decreasing with the y started decreasing with increasing of y, then it started increasing after certain point, then it started increasing, okay, after certain period, then it started increasing. So basically what is noise? Noise is the aberrant behavior, okay, of noise is what? It is the aberrant behavior, okay, of the independent variable when it influences the dependent variable, okay. So that is known as noise, isko hum bolte hain noise, this is known as noise, okay. So noise is what? That is the aberrant or abnormal behavior of independent variable when plotted against a dependent variable, okay, that is known as noise. But what is outlier? Outlier is the independent score or independent data point or points, okay, independent data point or points, okay, it may be one or two or it may be a single one, that is actually abnormal or aberrant, okay. So for example, Rohit Sharma's 264, that is an outlier because he never hits, every time he never hits 264, no, but he has hit it only single, no, in only once he has hit it, so that means this can be treated as a outlier, okay. So here I would say that this support vector machine is resilient to outliers, okay. Let it be the outlier present in the data, okay, let the outliers be present in the data, but support vector machine is resilient to that. I'll tell you how, okay. Okay, so please write all these points, then we'll switch to the algorithm. Okay, so yeah, so I discussed what is noise. Noise is nothing, it is the abnormal behavior, okay, a collective abnormal behavior of the data point, okay, the data, abnormal behavior of the data, right? When we plot the graph between the independent variable and dependent variable, and outlier is a single point, okay, but that is not a collective behavior, there is a single point that is actually I mean very much higher on the higher side, okay, but that is only okay, that is I mean outlier is, okay. So I think the differentiation between outlier and noise is what? That noise is the collective behavior of certain points in a data that are behaving abnormally from the entire data set. But what is outlier? A single point or one or two or three points that are actually abnormally on the higher side or on the lower side. That may also be the take, abnormally on the higher side or on the lower side, that may also be one of the things, okay. Chaliye ab, so yeah, this is outlier and noise, okay. Ab now firstly I'll just explain you how the support vector machine differs from logistic regression, okay, how support vector machine differs from logistic regression. So here what actually is that for example we have a independent variable, Okay, for example, we have a independent variable and we have a dependent variable. So in the logistic regression, what did we do? We tried to fit the sigmoid curve. Okay, in the logistic regression, what did we do? We tried to fit the sigmoid curve, and this sigmoid curve, okay, this sigmoid curve basically classifies the points. Okay, this sigmoid curve basically classifies the points. For example, I want to make a COVID predictor. Okay, for example, I want to make a COVID predictor. No, so what exactly this would do is a sigmoid curve would be fitted. Okay, and that would actually classify the points between yes and no. Okay, so for example, this positive means these are COVID positive points. Okay, so what does this positive means? These are COVID positive class, and what is this negative? This is the COVID negative class. So basically, what do we want? We want to fit a sigmoid curve that can actually separate the two classes. I hope this only we have studied, है ना? This only we have done in the logistic regression. ऐसे ही किया था हमने, यही चीज पढ़ी थी कि भैया वो क्या करता है? It actually try to fits the sigmoid curve that actually classifies, है ना, that actually classifies or differentiate between the positive class and the negative class. ऐसे ही होता था, है ना? This only we have studied. Okay, तो अब now instead of fitting a sigmoid curve, okay, instead of fitting a sigmoid curve, now what support vector machine do? It basically fits the hyperplanes. Okay, so instead of fitting a sigmoid curve, what support vector machine do? It says that I would fit a hyperplane. Why? Now the question is why I would fit a hyperplane. एक चीज बताओ भाई, यहाँ पे don't you think that if at all we have certain misclassifications, if at all we have certain misclassifications, so don't you think that we should have a certain phenomena, or we should have a certain approach that these misclassifications could be removed. Okay, so basically to improve the accuracy of a logistic regression model, okay, so what we do is he says, bhai, don't give me any sigmoid curve. I don't want any sigmoid curve from you. He says, bhai, you only give me hyperplanes along with support vectors that can actually differentiate certain important misclassifications. Okay, certain misclassifications, right? I hope you are able to see that. What are these? These are the mispredictions. Okay, what are these? These are the mispredictions, right? So अब now what support vector says? Support vector says कि भैया, I don't want any sigmoid curve, because sigmoid curve once fitted and certain mispredictions are there, they would be as it is. I can't do, okay, nothing I can do. So he says कि भाई, instead of a sigmoid curve, what do? You give me a hyperplane. Okay, अब now what exactly hyperplane is? I'll just make you visualize. Okay, what exactly hyperplane is? Yes, now what exactly hyperplane is? So instead of fitting a sigmoid curve, if it is if we have a single independent variable, then that hyperplane would be converted to what? It would be converted to a line. I hope you are able to visualize it, है ना? So it would be converted to a line. But if we have more than one variable, then you can see the hyperplane, no, that coming out of the board. I hope you are able to visualize this much. Okay, so instead of fitting a sigmoid curve, he has fit a hyperplane, and he tries to classify the data, to differentiate the data. Okay, and he tries to differentiate the data, right? He tries to differentiate the data. So this is the class red and this is class blue, or we can say positive class or negative class. Okay, or we can say positive class or negative class. Okay, or we can say positive class or negative class. Ab now here along with this hyperplane, ठीक है, what the algorithm says, along with this hyperplane, what the algorithm says? The algorithm says that instead of this, what I'll do is I would fit a hyperplane. Okay, chalo, that is good. Ab along with this, now for example, we have this positive class as I drawn here. So we have this positive class. Okay, we have this positive class. Okay, and we have a negative class. For example, this is the COVID negative class. Okay, for example, this is the COVID negative class. So now along with this hyperplane, what he would do, he would also draw support vector planes. Okay, he would also draw support vector planes. Okay, he would also draw support vector planes. Okay, now what exactly the support vectors are? Okay, just try to understand and make a note of it. It will really help you a lot. So this is what, yeah, firstly I'll just write, this is logistic regression. Okay, this is logistic regression and this is SVM. So along with this, along with the hyperplane that he fitted, he said कि भैया मैं क्या करूंगा, I would also fit two hyperplanes. Okay, and this hyperplane is what? This is the positive support vector plane. Okay, so this is known as positive support vector plane. Okay, why positive support vector plane? The plane that passes through the nearest, okay, please try to remember this, the plane that passes through the nearest positive point of the positive class is known as a positive support vector plane, and these 4 points are known as positive support vectors. Okay, so firstly I would like to make this very clear, support vectors can be more than one. Okay, there is no guarantee that we'll be having only 1 or 2 or 3 or 4 support vectors. There can be any support vectors. So what are support vectors? Support vectors are the nearest point. Okay, what are support vectors? They are the nearest point. So these 4 points are positive support vector. Okay, these 4 points are positive support vector, and these 3 points these 3 points are the negative support vector. Okay, these 3 points are negative support vectors, and the plane passing through the negative support vector is known as negative support vector plane. Okay, so this is known as negative support vector plane. Negative support vector plane. Okay, this is known as negative support vector plane. Okay, so this is how algorithm works. Okay, this is how algorithm works. So why these support vectors are drawn along with the main hyperplane? So these support vectors are drawn because, for example, if there are any misclassifications, अगर ये बोलता है कि if there are, for example, if there are any misclassification, for example, we have 2 misclassified points here and 1 misclassified points here. So what does this support vector says? He says कि अगर मेरे बीच में, if in between, okay, try to understand, if in between any misclassified points would come, I would be able to rectify it. So what this support vector says, if in between any misclassified points come by, what is this positive point? This is a misclassification. Okay, what is this? This is a misclassification. What is this negative point? This is a misclassification, because it should be here, no? Okay, it should be on the right hand side of the hyperplane, and this positive point should be on the left hand side of the hyperplane. So he says that I would draw 2 support vectors, and in between any of the negative or positive misclassified points come, I would be able to rectify it. Okay, I would be able to rectify it. Okay, so this is how the support vector works. Okay, this is the main approach of using a support vector algorithm. Okay, support vector machine algorithm. Correct. Yes. So yeah, yes. Newsbuster, actually, the noise, noise could be between these 2 planes also. Yes, that is a possibility. Yes, noise could be between these 2 planes. So he can rectify the noise as well as the mispredictions. So you just don't think that only noise is there. There can be mispredictions also. Okay, so that depends. Okay. Chalo, so I'll write the definition of support vectors and support vector planes. So now what are support vectors? Okay, now what are support vectors? So support vectors are the nearest points. Okay, support vectors are the nearest data points nearest data points from, they are the nearest data points from the hyperplane of the respective class Okay, so here if I just write positive support vector, so what is positive support vector? Very simple. What is positive support vector? Nearest positive points. Okay, I'll just write it. Nearest positive point. Okay, nearest positive point from the hyperplane. Okay, and what is negative support vector? Nearest negative point. Okay, nearest negative point from the hyperplane. Okay, nearest negative point from the hyperplane, right? So this is positive support vector and negative support vector. And what is the support vector plane? So support vector plane is what? I'll just write it here. What is support vector plane? So plane passing through. Okay, plane passing through the support vectors. Plane passing through the support vectors are called as support vector plane. Okay, plane passing through the support vectors are known as support vector plane. Okay, plane passing through the support vectors are known as support vector plane. Okay, so please write it. Then let us move forward. Okay, support vector plane is an important topic and number of questions have come. So I'll make you do all these questions today itself and you'll be able to solve really very easily. Okay, that is my promise. Okay, just focus what I'm teaching now, just focus on that. Okay, I promise you'll be able to do it very easily. Okay, we have 2 questions. Okay, chaliye. Now again I'll just draw this. I'll draw this. For example, we have a independent variable and a dependent variable. Okay, if it is if we only have a single variable, no, if we only have a single independent variable, so I am drawing a graph between independent variable and dependent variable. Okay, so we only have a single variable in the data set. So yes, so I just draw a graph between x and y, and this is the hyperplane. Okay, this is the hyperplane that we have fitted, main hyperplane. Okay, that actually differentiates between positive and negative class, and along with this we have positive points. Okay, we have certain positive class points and we have certain negative class points. Okay, we have certain negative class points. Okay, so the plane that would pass through the nearest positive points is known as positive support vector plane, and plane that would pass through the nearest negative points, that is known as negative support vector plane. Okay, that is known as negative support vector plane. So this is a negative support vector plane, and this is positive support vector plane. Okay, this is positive support vector plane. चलिए, now here I would define margin of separation. Okay, now here I would define an important point, that is margin of separation. Okay, so it is defined as the distance between, the two support vector planes. Okay, so this is known as margin of separation. So the distance from main hyperplane to the positive support vector plane, that is positive margin of separation, and distance from main hyperplane to the negative support vector plane, that is negative margin of separation. Okay, that is known as negative margin of separation. So this is known as D minus. So what is D? If I just club both of these, so this is known as D. Okay, so D is defined as margin of separation. Okay, this is defined as margin of separation, which is equals to D plus and D minus. Okay, and what is D plus? D plus is known as the positive margin of separation, and D minus is known as the negative margin of separation. Okay, so at times we call this as margin also, or margin of separation also. Okay, so at times we call it as margin also and margin of separation also. Okay, so here in this learning algorithm, so we have to make sure, okay, in this, I'll just write certain important points. So in this learning algorithm, no, in this algorithm, we have to make sure, okay, we have to make sure that all the positive points, we have to make sure that all the positive points shall lie above the positive support vector plane. All the positive points shall lie on or above the positive support vector plane. Okay, and likewise for negative also. Okay, likewise for negative also. Okay, and if certain points doesn't lie, for example, we have certain mispredictions here, so those points would be counted in mispredictions. Okay, so yahan pe I would write mispredictions may exist. Okay, mispredictions may exist, but yes, we would like to, okay, understand, but we would like that all the points of the positive plane should lie above this positive support vector, and all the points of the negative plane should lie on or below the negative support vector. If at all there are certain mispredictions, then let it be. Okay, let it be, no worries. So we'll just rectify them. Okay, so we'll just rectify them. Okay, ab now okay, अब now if yes, if misprediction occurs, next point would be if misprediction occurs. Okay, अब now if misprediction occurs, okay, if mispredictions are there, if mispredictions are there, we try to rectify the mispredictions. Okay, we try to rectify the mispredictions and the hyperplanes are regenerated. Okay, we try to rectify the mispredictions and hyperplanes are regenerated. Okay, very important, hyperplanes are regenerated. For example, we have any misprediction here. Okay, for example, this positive point is here and this negative point is here, okay, and we have a negative point here. So these two are what? These two are the mispredictions. So we'll try to rectify this, okay. So how to rectify it? So we'll try to make this point rectify this point to their respective classes, and we'll try to make this point jump to their respective classes, okay. So how do we do this? We would try to regenerate the hyperplanes, okay. We would try to regenerate the hyperplanes, right? तो अब hyperplanes अब दोबारा से बनेंगे. We'll make these hyperplanes again, okay, so that now in between those there shouldn't be any misprediction, okay. मतलब every time what we'll do is we'll try to regenerate the hyperplanes, right? So we'll try that this should come here, this should go there. How? By regenerating the hyperplanes. Again we'll try to regenerate. मतलब how to regenerate? In 3 dimension that would be regenerated, okay. So you are only seeing in 2 dimension, but in 3 dimension that you would be it would be regenerating, okay. So here certain visualization is important, right? So here you have to visualize this. I'll explain it once again, okay. Dekho, what happens is that this is only a 2D view. I hope you are getting this. This is only a 2D view. I'll show the 3D view. So what is the 3D view? Yeah, this is the 3D view. See here. Now just try to visualize here, okay. We have 2 classes, okay. In the this left graph we have 2 classes. Just try to visualize. In the left graph we have 2 classes, the positive class and the negative class. Now just imagine that if at all we have mispredictions here, just try to imagine that if at all we have mispredictions here, then the new support vectors would be generated. Here there is no support vector plane, okay, but if at all mispredictions are there, I would try to generate the new support vectors in 3 dimension or 4 dimension or 5 dimension. That depends what is the dimension of the data set, okay. But yes, again the new orientation of support vectors would be generated so that mispredictions can be avoided, okay. So that mispredictions can be avoided up to a certain limit. Not every misprediction can be avoided, but yes, the maximum that we can avoid may be avoided. So in 3 dimension you just imagine that I am trying to again regenerate the support vector planes, okay. So I can change the orientation in any of these directions. I hope you are able to see this. Not only this I can change in any of these directions. I hope you are able to visualize it. So that is how these support vectors would be regenerated, okay. So there is the game of visualization here, okay, so that the mispredictions may come to their respective class, okay. Mispredictions may come to their respective class, okay. So I would just say, what is the goal? Now I would just try to explain the goal of what is the goal of SVM, okay. What is the goal of support vector machine? Okay, what is the goal of support vector machine? The goal of support vector machine is to maximize the margin, okay, to maximize the margin, okay, to maximize the margin, okay. What is margin? D. So that the accuracy of the algorithm improves. So that the accuracy of the algorithm improves. I need to maximize the margin so that the accuracy of the algorithm improves. So this is the major goal of the support vector machine, okay. This is the major goal of the support vector machine. So I hope you are able to visualize that I would try to change the orientation or any direction, okay, yeah, direction of this hyperplane, okay. There is no limitation that I would change this way only. Na, zaruri nahi hai. I can change in any of these directions, okay, because that plane could be rotated in any form, no. So yes, so we can change the direction of the support vector planes so that the mispredictions can be limited, okay. They can be eliminated, not completely, but yes, partially also. So if I eliminated the mispredictions partially, then also my accuracy is improved. I would be improving my precision, I would be improving my recall, I would be improving my F1 score. So that means the prediction would improve, okay. So this is the major goal of support vector machine. So bit visualization is required, okay. I would say bit visualization is required, and if at all you are not able to visualize, no worries, just work with me along on the questions and the concepts. Question you would easily able to attempt, okay. Just don't worry. And this is one of the 2D graphs. This is one of the 2D graphs where this support vector machine is trying to maximize itself, okay. This is one of the 2D graphs where the support vector machine is represented here, okay. So this is the hyperplane, okay, and here we have the support vectors. So based on the data set along with the misprediction, so we'll try to maximize it. Okay, we'll try to maximize it. So if the margin is maximized, okay, if the margin is maximized, you just see, if the margin is maximized, तो that means कि इसके अंदर की जितनी भी mispredictions होंगी, you just try to understand, if the margin is maximized, so that means the mispredictions between these would be able to rectify it. Okay, that I would be able to rectify partially or completely, that depends on the data set. But if I'm trying to maximize this, अगर मैंने इसको maximize कर दिया, तो mispredictions occurring in between this may be eliminated partially or completely. Okay, so shape generally doesn't change. Okay, shape depends on the dimension of the data set. If we have two dimensions, x1 and x2 are there, so then it would be a simple hyperplane. But if, for example, if we have 10 dimensions, so then that hyperplane would be very complex. I hope you are able to visualize it, Newsbuster. Okay, so this is somewhat the approach of why support vector machine was designed, because logistic regression for a binary class or for multi-class was not accurate. So what did they decided? तो mathematicians decided that भाई मैं कुछ ऐसा करता हूँ कि इसको हटाओ, sigmoid को हटाओ, just leave sigmoid. What I'll do is I would try to make a hyperplane along with two support vectors. और कुछ भी अगर होता है, कुछ भी गड़बड़ होती है in between these two hyperplanes, that I'll be able to rectify it. And what is my goal? इसको चौड़ा करो. Just maximize this separation. Okay, this margin of separation maximize. तो कोई भी फालतू का अगर कुछ भी होता है इसके बीच में, भाई वो तो मैं देख ही लूंगा ना. तो this is how the support vector machine was approached. Okay, that is how the support vector machine was designed. ठीक है, तो ये पंगा था. चलिए अब यहाँ पर फॉर सॉल्विंग द क्वेश्चंस इन गेट, जस्ट बी विद मी. ओके, एंड लेट अस डू सर्टेन क्वेश्चंस ऑन इट. ओके, तो फर्स्ट वन वुड बी, तो फर्स्ट वन वी जस्ट अंडरस्टैंड द गोल, ओके, एंड मार्जिन ऑफ सेपरेशन. चलिए अब नाउ नेक्स्ट इज again I'll be just drawing the support vector machine graph. Okay, support vector machine x. This is x, and this is dependent variable y, and okay, this is the main hyperplane, right? So now how the hyperplane equations are written? So they can be written in this form: ax plus by plus c equals to 0. Okay, I hope you remember the main hyperplane equations, no? That can be written as ax plus by plus c equals to 0. Okay, and if I just want to convert this into a standard form, no? So how you can convert? So you can convert by equals to minus ax minus c, and y is equals to minus a by b into x plus minus c by b. Okay, minus c by b. So this is the slope of the hyperplane. Okay, please this you should remember. Okay, this is the slope of the hyperplane. Okay, if at all you forget the concept, here for support vector it is required. Okay, this is the slope of the hyperplane. Okay, and this is the intercept of the hyperplane. Okay, this is the intercept of the hyperplane. So this concept you should remember. Okay, this concept you should remember. So that is the slope and that is the intercept. Okay, now I am giving you the equation of the hyperplane as y equals to 0.5x plus 1. Okay, y equals to 0.5x plus 1. Okay, I'm giving you this equation of the hyperplane y equals to 0.5x plus 1, right? Now tell me, now I'm giving you 2 points. Okay, I'm giving you 2 points. Yeah, the first point is point A. Point A is 4,7. Okay, I'm giving you 2 points. So point A is that is 4,7. I'm giving you a second point, point B, that is 3,1. Okay, that is 3,1. I want you to calculate y 4,7 and y of 3,1. Okay, just calculate the value of these 2 points for this main hyperplane equation. Okay, everybody, please try this. Okay, so if you just calculate y of 4 comma 7, how to calculate this? So this would be y minus 0.5x minus 0.1, and I'll just put x equals to 4. Okay, I'll just put x equals to 4. So 0.5 into 4, okay, minus 1. Okay, so yeah, so I'll just put x equals to 4 and y equals to 7, right? So I would be getting 7, yeah, minus 0.5 into 4 minus 1. Okay, and here y3 comma 1, so here I would be getting y minus 0.5 minus 1, so I'll be just putting y equals to 3. Okay, I'll just put y equals to 3 minus 0.5 into yeah, so y equals to 1 minus 0.5 into 3 and minus 1. Okay, minus 1. See, I'll just take everything here. No, I have to take everything here or this to here. So what I'll do is I'll just take everything in this form. Okay, I'll just take everything in this form, right? I hope you are getting this. So I'll just convert everything in this form. So now what I'll do is I just put x as 4 and y as 7. Okay, and here I put x as 3 and y as 1. Okay, so if you just see y 4 comma 7, no, so you would be getting positive value. Okay, here you would be getting positive 4. Okay, so you would be getting plus 4, and y 3 comma 1, so here you would be getting negative of 12. Okay, here you would be getting, yeah, negative of 12. No, I'll just calculate it again. Yes, 7 minus 1. Just a second. Let's calculate this. Yes, so here I'll be getting positive 4, and here I would be getting, yeah, here I would be getting negative of 1.5. Okay, here I would be getting negative of 1.5. Okay, अब now the thing which you have to see here is, अब देखिए यहाँ पर आपको क्या देखना है? The thing which you have to see here is that y of 3 comma 1 that belongs on the one side of the hyperplane is coming negative, and y of 4 comma 7 that belongs to the other side of the hyperplane that is coming positive. So what does that mean? It means that if any of the point that is on the negative side, okay, I am treating this as the negative side, okay, that is I am treating this, I am considering this as the negative side or the negative class. So on one side of the hyperplane, all the values would be negative. Okay, try to understand this. On one side of the hyperplane, all the values would be negative, and on the other side of the hyperplane, all the values would be positive. So that means that negative class and positive class has been separated by this hyperplane. Okay, that means negative class and positive class is separated by this hyperplane. Okay, and if I take any point on this hyperplane, for example, I take a point C. Yeah, I take a point C. Okay, that is 5 comma 3.5. okay, this is 5 comma 3.5. I take a point C, that is 5 comma 3.5, right? And just try to calculate this value y of 5 comma 3.5. just try to calculate this value 5 comma 3.5. what is the value of this? So I am damn sure that this value would come equals to 0. Okay, you just put all these points, y 3.5 and x as 5. Okay, so you would be getting this value as 0. Okay, so that means, what does that means? Any point on the hyperplane, okay, if you are putting any point on the hyperplane, that would give you a result 0. Any of the point that you are putting on the one side of the hyperplane, that would give you a result positive, and on the other side of the hyperplane, all the points belonging to the other side of the hyperplane, that would give you the result negative. So that means this hyperplane would act as a classifier. Okay, that means this hyperplane would act as a classifier that would actually separate the positive class with the negative class. Okay, that would separate the positive class with the negative class. So that means I can say that a point 4 comma 7, I can say the point 4 comma 7, point A, that is 4 comma 7, okay, belongs to positive class. Okay, it belongs to positive class. Okay, positive class or class A. I am considering that this is positive, no? Yes, yes, I think it would come, no, RxU, if you just put these points, no, 5 comma 3.5, if you just put it here, I hope you are able to see, no, I'll just put all these points here. See, y is what? Y is 3.5 minus 0.5, okay, 0.5 into x. So into x, what is x? That is 5, and minus 1, okay. So minus ka 2.5, minus ka 1, that is minus 3.5 and plus 3.5. So this would come around 0, no? I hope you are able to guess this. Okay, so correct. Okay, so that means point A, that is 4 comma 7, belongs to positive class. Point B, okay, point B is what? 3 comma 1, this belongs to class negative, okay, or class B. Okay, anything you can say, this belongs to a negative class or class B. Okay, any way you can say. I just assume that the positive points belongs to positive class, negative points belongs to negative class. Okay, and point C, that is what? That is 5 comma 3.5, that lies on the hyperplane or the decision boundary. Okay, so this point, so it lies on the decision boundary. Okay, it lies on the decision boundary. So whenever you are asked to justify or asked to determine whether this point belongs to a positive one or a negative one, so how to determine? Just put that point in the hyperplane. Okay, if anyone asks you that what exactly this point, I mean this point belongs to class A or B or positive class or negative class, just put that point in the main hyperplane equation. You would get where this point belongs to. Okay, you would get where this point belongs to. Okay, so this is how we have to do this. Okay, this is how we have to do this. ठीक है. अब now how to calculate, yeah, No, no, there would be only a single hyperplane, Newsbuster. There would be only a single hyperplane, but that may be regenerated. That would regenerate, okay, number of times to improve the prediction capability. Okay, so that can regenerate, but there would only be a single hyperplane. Okay, yes. अब now, how to calculate the d plus value? Okay, so how to calculate the d plus value? I'll just write the formula. Okay, how to calculate d plus value? So that is ax plus by plus c upon under root of a square plus b square. Okay, this is how d plus can be calculated. And d minus, how to calculate d minus? So d minus, again we can calculate this as mod. Okay, this is mod of ax plus by plus c upon under root of a square plus b square. Again d minus would be mod of ax plus by. Okay, mod of upon under root of a square plus b square. Okay, so this x and y, what I'll put here, what I'll put in x and y, the positive class points. I hope you are getting this. I would put the positive class points, and here in x and y, what I'll put? The negative class points. Okay, so this I'll put negative class points. Okay, I'll put the negative class points. ठीक है, अब combinedly what I'll say, combinedly what I can say, if I just combine this, no, if I just combine it, so what I can say the value of d would be, c2 minus c1 upon under root of a square plus b square. Okay, c2 minus c1 upon under root of a square plus b square, and the, mod of c2 minus c1. Okay, so just write this formula. Okay, very important, just write this formula. So if at all you doesn't remember anything, this you should remember. Okay, this is important. Okay, okay, so this is important, this formula is important, so you should remember this formula. So margin of separation is defined as c2 minus c1 upon under root of a square minus b square. Okay, and here also write c1. Yeah, here this c1, also write c1 here. Okay, this is c2. Okay, and I'll just draw the diagram also. So this is main hyperplane, ax plus by plus c, that is equals to 0. Okay, then parallel hyperplanes, then parallel positive hyperplanes, so this is ax plus by plus c1, that is equals to 0, and this is the negative support vector plane. Okay, this is negative support vector plane, ax plus by plus c2, that is equals to 0. Okay, so this is the main hyperplane, this is the positive hyperplane, and this is the negative hyperplane, right? So based on this, this is d plus. Okay, I hope you are getting this. This is d plus, right? This is d minus, and after combining this, I would be getting this. Okay, mod of c2 minus c1 upon under root of a square plus b square. So please draw this diagram also, it would make the concept really very clear. Okay, so this is independent variable, dependent variable, main hyperplane equation, negative support vector plane, positive support vector plane, and the distance between these two. And the distance between these two is known as the margin of separation. Okay, this is known as the margin of separation. So this is the concept. Okay, this is the concept that you should remember, right? So this is the positive support vector plane, negative support vector plane, the distance between two, that is d, that is mod of c2 minus c1 upon under root of a square plus b square. Okay, I am just giving you a question, very simple question. For example, I have a graph between dependent variable and independent variable. The main hyperplane equation that is given as 4y, yeah, equals to 2x plus 4. Okay, 4y equals to 2x plus 4. The positive support vector hyperplane equation, and this is negative support vector hyperplane equation. The positive support vector hyperplane equation is 4y equals to 2x plus 5. Okay, 4y equals to 2x plus 5, and this is 4y equals to 2x plus 3. Okay, and this is what you need to calculate. Okay, you need to calculate the value of d. What is the value of d? Everyone, please try to calculate. So formula is what? Formula is c2 minus c1, c2 minus c1 mod upon under root of a square plus b square. Okay, so c2 minus c1 mod. So what is c1? That is 5 minus 3. Okay, mod upon under root of a square plus b square. So I'll firstly convert this into this form, no? 4y minus 2x minus 4 equals to 0. So a square plus b square, right? So what is a square? Minus ka 2 square, and what is b square? 4 square. Okay, so this is how I'll be calculating, right? So what is the answer? Yes, everyone, please calculate what is the answer. Yes. Okay. So, sorry, this we have to also convert. No. This we have to also convert into this form. Okay. Yeah, I've written is wrong. We have to convert this also into this form. So 4y minus 2x minus 5 equals to 0, and this is 4y minus 2x minus 3 equals to 0. Okay. So here what is C1? C1 is minus 5, and here what is C2? C2 is minus 3. Okay. So please correct it. No. Yeah, by mistake I've written this. So C2 minus C1. So this is how you have to write. Okay. C2 minus and minus of 3. So this is how we have to write it. This is the correct one. Okay, so this is the correct one. Though answer wouldn't change. Yeah, though answer wouldn't change. Sidhu is correct. Okay, Sidhu is correct. Though answer wouldn't change, but yes, this is the correct way to write so that it would be clear to you. Okay, so answer would be 0.447. Okay, so answer would be 0.447. Okay, so now I would like to summarize the point. So what we have actually studied, I would just like to summarize the point. For example, this is independent variable, this is dependent variable, this is main hyperplane equation, and this is ax plus by plus C, that is equals to 0. Okay, then we have positive support vector plane, that is a parallel one. Okay, that is the parallel to the main hyperplane equation, ax plus by plus c1, that is equals to 0. And we have negative support vector plane, okay, again parallel to the main hyperplane equation, ax plus by plus c2, that is equals to 0. So what we have studied, so till now we saw that if point belongs to the positive class, okay, if point belongs to the positive class, if data point is positive, so that means ax plus by plus c should be greater equal to 1. Okay, very important. If the data point is positive, that means ax plus by plus c, that should be greater equal to 1. Okay, so agar ax plus by, here also we have two cases. So agar ax plus by plus c is equals to 1 and ax plus by plus c, that is greater than 1, so that means point is on the positive support vector. Okay, point is on positive support vector, point is on positive support vector plane. Okay, this understanding you should have. I hope you are able to visualize this. Okay, point would be on the positive support vector plane, and if it is greater equal to 1, so point is above the positive support vector plane. Okay, point is above the positive support vector plane. Okay, and next is that if data point belongs to negative class. Okay, if data point belongs to negative class, so there ax, yeah, so I can just write ax plus by plus c, that would be less than equals to minus 1. Okay, that would be less than equals to minus 1. Again, we have two conclusions from here. Okay, you have to write both the conclusions. Again, we have two conclusions from here. If ax plus by plus c, that is equals to minus 1, and the next is if ax plus by plus c, that is greater than, that is less than minus 1. Okay, that is less than minus 1. So here point is on the negative support vector plane. Okay, point is on the negative support vector plane, and here point is beyond, okay, below the negative support vector plane, and here point is beyond the negative support vector plane. Okay, so this is the conclusion that I have given to you, very important, and one question is entirely based on this conclusion. Okay, so you just write it. Okay, we'll take a 15 minutes break. Okay, so you just write it. Now we'll take a 15 minutes break and then we'll be back. Okay, chaliye, so let us meet at 12:05 p.m. Okay, so it will be good. Okay, just go freshen up yourself. Let us meet at 12:05. Okay, chaliye, let us start again. Chaliye, let us start again. So we have discussed, yeah, so we have discussed certain points regarding the main hyperplane equation. Okay, and we have discussed certain points uh, regarding the support vectors, how data points are classified, and what exactly the approach is before building a support vector machine algorithm. Okay, what approach is for building a support vector machine algorithm. Okay, so now I would just give you certain questions. Okay, one of the question that appeared, in GATE 2025. Okay, I'll just give you that question and I'm pretty sure you'll be able to do this, right? Acha, this is one of the animations, no, where actually the hyperplanes are getting regenerated. Okay, I think Newsbuster was asking me, sir, is there only a single hyperplane? Yeah, we have a single hyperplane, but again it is again and again it is regenerating, because what is my goal? My goal is that I need to maximize it. I need to maximize the margin. Okay, but yes, only up to a certain level only I can maximize the margin, no? So up now, if at all misclassifications are there, so what I'll do is I'll try to change the orientation of the plane, and not only this way, I can change into any of these points. I hope you are getting this, no? This means in 3D in any direction it can change, so that the misclassifications may get reduced. So this is the main funda of support vector machine. Okay, this is the main funda of support vector machine. Okay, चलिए अब यहाँ पे now I'll just give you one GATE question, no, that actually appeared in 2025. चलिए, तो this is the GATE question that appeared in 2025. Okay, yeah, but before this I just want to clear one more concept, then only you will be able to solve this. A very simple concept. Okay, before this I just want to clear a very simple concept. Now we know that this is the equation of the main hyperplane, this is the negative support vector, this is the positive support vector, and distance between this is known as margin. Okay, distance between this is known as margin. Okay, acha, at times what exactly they do is, at times what exactly the GATE people do is, what they would do is they would give you in the vector form. Okay, they would give you the equation in the vector form. Okay, do write this in the formula sheet, बेटा लिख लीजिए, मैं आपसे डेफिनेटली कह रहा हूँ बहुत काम आएगा. They would give you in the vector form. ये लोग क्या करते हैं ना, what they are doing, अब 2025 में भी यही दिया है. This only they have given you in 2025 also. This only they have given you. The concept is that instead of writing ax plus by plus c equals to 0, what they would be writing is they would write weight transpose into x plus b, that is equals to 0. This is the equation of the main hyperplane. Okay, the equation of positive hyperplane, is weight transpose into x plus b, that is equals to positive 1, and the negative hyperplane equation is weight transpose plus x plus b, that is equals to negative 1. Okay, weight transpose plus into x plus b equals to positive 1. This is for positive hyperplane, and for negative hyperplane is weight transpose into x plus b, that is equals to negative 1, right? Now I would tell you, अब now I would tell you what exactly this weight and this b is. देखो the equation, the standard equation क्या थी जो हमने पढ़ा था? The standard equation was ax plus by plus c that is equals to 0. Okay, this was the standard equation that we have studied. Okay, this was the standard equation that we have studied. अब यहाँ पर हम क्या करेंगे? I would be converting this. Okay, this equation would be converted to weight transpose into x plus b that is equals to 0. Okay, ये b अलग है, ठीक है, this b is different. तो मैं यहाँ पर छोटा b लिखता हूँ, I'll just write small b. Yeah, so I'll write small b plus b that is equals to 0. Where what is weight? Weight are the coefficients. Okay, weight are the coefficients of the independent variable and dependent variable. So I'll just write this as a, I'll just write it as small a and small b. Okay, so these are the coefficients. Okay, so this is what? This is the coefficient of independent variable, or what is b? What is small b? Okay, अच्छा इसको c कर देते हैं, नो वरीज, इसको मैं c कर देता हूँ, ठीक है. आई जस्ट मेक दिस एज c फॉर योर better clarity. I just make this as c, and this is the coefficient of dependent variable. ठीक है, coefficient of dependent variable. ठीक, and what is this b? b is the constant. ठीक है, what is this b? b is the constant. तो यहाँ पे ये जो b है that is known as constant. तो कुछ भी नहीं है, very simple, कुछ भी नहीं है. आपको अब ये इक्वेशन भूल जाना. You just forget this equation that we were doing in this form. Just forget this. Only remember this. So you would be given what? You would be given the coefficients of what? Coefficients of independent variable and dependent variable, right? This small a is different from capital A. Okay, this small is different from capital A, right? And this small c is different from capital B. But these are the coefficients only. They are the coefficients only of independent and dependent variable respectively. And what is this b? This is the constant. Okay, what is this b? This is the constant. So if I need to convert this to this, so how to convert this? Very simple. How to convert this? If I want to convert, yeah, if I want to convert here to here, so very simple. So I can just write that this would be ax plus by plus c equals to 0. So what I'll do is I would be dividing this a by c into x. Okay, b by c into y plus 1 equals to 0. Okay, a by c into x plus b by c into y plus 1 equals to 0. Okay, or what I can do is I'll just go the other way. What I'll do is I'll just go the other way. Yeah, I'll just go the other way. So yes, I'll just go the other way. Now I'll just take this equation. Okay, weight transpose into x plus b equals to 0. So what I'll do is I'll just write the coefficients of this. Okay, I'll just write the coefficients of this. So a and c transpose, and what is x and y? Okay, what is x and y? What is x? So this is independent variable and dependent variable plus b equals to 0. ठीक है, तो ये क्या आ जाएगा? तो this would be what? This would be, हाँ, तो यहाँ पे लिख देता हूँ, ये क्या आ जाएगा? तो this would be a and c. Okay, x and y plus b that is equals to 0. तो अब आप इसको मल्टीप्लाई करोगे ना, तो this is what? This is a 1 cross 2 vector, this is a 2 cross 1 vector. Okay, so when you would be multiplying this, so you would get ac, yeah, you would be getting ax, okay, ax plus cy plus b equals to 0. मतलब वही चीज आ जाएगी. I hope you are able to understand. No, I hope you are able to understand. I would be getting this only. मतलब I would be reaching here only. आप देखो, this and this are almost similar. Okay, so I would be reaching here only. Okay, so at times you would be I mean you would be given the equation in this format. Okay, At times you would be given the equation in this format, weight transpose into x plus b equals to 0. Okay, just don't get confused, nothing, very simple. भैया ये जो weight है, what is this weight? These are the coefficients of x and y. अब यहाँ पर I have specified this with a and b, कोई बात नहीं, let it be, but actually they are nothing, these are just the coefficients of x and y. So for example, I just took a and c as the coefficients in the other form in this weight matrix. Okay, that is what? That is 2 cross 1. Okay, that is what? That is 2 cross 1. And what is this x? This x are the variables. Okay, what is this x? This x are the variables. So I'll just write here x. Okay, I'll just write here x. So what is x? X are the variable. So I'll firstly write independent and then I would write dependent. Okay, and this is also a 2 cross 1 matrix. ठीक है, तो कुछ भी नहीं है, बहुत सिंपल है, वेरी सिंपल, कुछ भी नहीं है, सिर्फ भाई ये एक मैट्रिक्स को लिखने का तरीका है. इट इज जस्ट अ मेथड टू राइट द मैट्रिक्स, बस, और कुछ भी नहीं किया मैंने, राइट. तो व्हाट आई हैव डन, आई हैव रिटन AC, दिस इज द मैट्रिक्स इन द मैट्रिक्स फॉर्म, द कोएफिशिएंट ऑफ x and y. देन व्हाट इज x? x, these are the variables, independent variable, dependent variable. तो I just took transpose of weight vector, I just took as it is the variable vector plus b equals to 0. So I would be obtaining the same form as from where I started. Okay, I would be obtaining the same form from where I started. But guys, this C, okay, this C and this B are entirely different. Don't get confused. Okay, yes, Newsbuster, very good question. बेटा ये वाला जो C था और यहाँ पर ये थोड़ा अलग है, that is different. Okay, मैंने बस आपको ये बताया कि ये और ये फॉर्म ऑलमोस्ट सिमिलर है, ये और ये फॉर्म सिमिलर ही है, बट डोंट गेट कंफ्यूज कि सर ये A और ये A बराबर है. नहीं, हो भी सकता है, नहीं भी हो सकता, बट ओके, आई जस्ट वांटेड टू टेल यू दैट दिस फॉर्म एंड दिस फॉर्म इज सिमिलर. तो एक्चुअली आई स्टार्टेड फ्रॉम हियर, actually I started from here, but at times what the gate people do is they give you in the matrix form. Okay, and why matrix form is important? Because in the Jupyter na, in the backend, everything actually is running in that matrix form. So that is why this matrix form is important. Okay, इसलिए वो matrix form में देते हैं, every time they give in the matrix form. तो guys, don't get confused, यहाँ पर confuse नहीं होना, ठीक है. जस्ट डोंट गेट कंफ्यूज कि सर क्या ये A और ये बराबर है, हो भी सकता है, नहीं भी हो सकता है, हमें तो कोई मतलब नहीं है भाई, हम तो अब इसी को सच मानेंगे. आई वुड जस्ट ट्रीट दिस एज दिस इज द ट्रूथ. ऊपर कुछ भी था, मेरे को मतलब ही नहीं है, ठीक है, ठीक है. तो आई जस्ट टेक दिस एज ट्रूथ. तो बेसिकली दिस इज नथिंग. तो वेट ट्रांसफर इनटू x प्लस b इक्वल्स टू 0. अब नाउ तो कंक्लूजन विच आई कैन ड्रॉ फ्रॉम हियर इज, तो weight transpose into x plus b, that is equals to 0. So this is the equation of what? This is the equation of main hyperplane. Okay, this is the equation of what? This is the main hyperplane equation. Okay, main hyperplane equation. अब यहाँ पर we have two things, weight transpose into x plus b greater equals to 1. Okay, weight transpose into x plus b greater equals to 1. So here we have two types. Okay, we have two conclusions to make. So weight transpose into x plus b equals to 1 and weight transpose into x plus b greater than 1. So if it is equals to 1, so point lies on the positive support vector. Okay, point lies on the positive support vector. If it is greater than 1, point lies beyond positive support vector. Okay, if it is greater than 1, point lies beyond positive support vector. Now weight transpose into x plus b less than equals to minus 1. Weight transpose into x plus b less than equals to minus 1. Again, I have two conclusions to make. If weight transpose into x plus b, that is equals to minus 1, and weight transpose into x plus b less than minus 1. Okay, so here point lies on negative support vector plane. Okay, point lies on negative support vector plane, and here point lies beyond negative support vector plane. Okay, point lies beyond negative support vector plane. So guys, just write this. Soon after this, we'll be doing one GATE 2025 question. Okay, please write it. I'll wait for a minute. Okay, now if anyone has doubts, sir, आपने कैसे convert किया? How did you convert it? This question is for you. Just attempt this question. Okay, this question is for you. Just attempt this question. How to convert this 4y equals to 2x plus 4 in this format? Very simple. This question is for you. Just attempt this question. Okay, so yeah, so this you have to do as a homework, so you'll be able to understand. Okay, again, so this is how we have to convert it. Very simple, no? So this is the format. This is the format that you would be given. And how did we convert it into weight transpose into x plus b? So this is the one that we have converted. So what with the value of b? What is weight? The coefficients of weights. So you'll be given here. Okay, so just after the class, just give 2 minutes on this page. Very easily you will be able to get how to convert this form ax plus by plus c into this matrix form. Okay, very simple, you will be getting it. Okay, very easily you will be getting it. Okay, correct. Chaliye, ab now just solve this question. Okay, this appeared in GATE 2025 for 2 mark. I want everyone should do this correct in your first attempt. Okay, please everyone do this, bacha. Okay, here we have this hard margin support vector. For now, you just leave this word hard margin and only stick to the fundamentals that we have studied. Okay, just leave this word hard margin. I'll tell you. Okay, in the end, I'll tell you what this hard margin is and what a soft margin support vector machine is. Okay, just leave this word hard margin and just focus on the concept till now what we have studied. Okay, chaliye bacha. This is MSQ question, right? More than one is correct. More than one is correct. Yeah, more than one is correct. Okay, chaliye, how to do this? Let us solve this question. GATE 2025, 2 mark question. Okay, I'll just solve it for you. Okay, so now firstly what I'll do is I'll just draw a graph because we have certain points from class A and B, right? So class 1 points are 2 0 0 2 2 2. Okay, class 1 points are, I'll just write here, class 1 points. Class 1 points are, yeah, so 2 0 0 2 2 2. Okay, 2 0 0 2 2 2. 2 0 0 2 and 2 comma 2. Okay, and class 2 points. Class 2 points. So class 2 points are 0 comma 0. Okay, so class 2 points are 0 comma 0. I hope you are able to get that this is a binary class data set. I hope you are able to get that this is a binary class data set. ठीक है, आई होप आप समझ पा रहे होंगे कि ये बाइनरी क्लास डेटा सेट है. चलिए अब नाउ वी हैव दीज पॉइंट्स. ठीक है, अब देखो, अब हमको क्या करना है, अब हमको ऑप्शंस में बताना है. आई हैव टू जस्ट टेल व्हाट ऑल ऑप्शंस आर करेक्ट. ओके, चलिए फर्स्टली व्हाट आई विल डू इज आई विल जस्ट मार्क ऑल दीज पॉइंट्स. ओके, फर्स्टली व्हाट आई विल डू इज आई वुड जस्ट मार्क ऑल दीज पॉइंट्स. सो फॉर एग्जांपल दिस इज 0, दिस इज 1, दिस इज 2 3 4. Okay, this is 1 2 3 and 4. Okay, so class 1 points I'll be marking with a separate color, that is 2 comma 0. So this is first point, then 0 comma 2, this is next point, and this is the third point. Okay, so this is class 1 points I have marked with this color, and next point is what, 0 comma 0. Okay, so I am marking this with a different color, right? So this is 0 comma 0. Okay, so this is class 2 point, right? Ab now what does he says? He says that consider designing a linear binary classifier where f of x is sine of w. Okay, just leave it. Okay, just leave it. ठीक है, on the following training data. Okay, so this is how actually support vector machine, hard margin support vector machine is designed. So we'll do this, no worries. Okay, अच्छा, अब he says a hard margin support vector machine formulation is solved to obtain W and B. आप ये समझ के चलो, we have to obtain what, W and B. Okay, we have to obtain what, we have to obtain W and B. तो हमको W और B. तो what is W? I hope you are now able to understand, no, what W. W is weight transpose into X plus B, that is equals to 0. Okay, so what is W? W is nothing, weight matrix. Okay, what is W? W is nothing, that is weight matrix. Okay, what is X? X is the variable matrix. Okay, what is X? X is the variable matrix. Okay, and what is B? B is the constant. Okay, what is B? B is the constant. अच्छा, अब यहाँ पर क्या कह रहा है, we need to calculate this. चलो ठीक है, अब he says that which of the following options is are correct. Okay, which of the following options is are correct. अच्छा, अब अगर आप यहाँ पर देखो, for example, if you just see here, okay, for example, if I want to draw, see, for determining the support vectors, we should draw the support vector plane, and before that we should draw the main hyperplane. मानते हैं ये चीज? I hope everyone agrees कि भैया अगर मुझे support vector निकालना है और support vector plane निकालना है, तो उससे पहले what I'll do is I would draw a main hyperplane equation. Okay, so whenever such question comes, always try to, okay, always try to draw the main hyperplane equation on this graph. So if you just see that they belongs to class 1, this point belongs to class 0. So if you just see, this could be one of the main hyperplane equation. Okay, if you just see, this could be one of the main hyperplane equation. Okay, so if at all question comes, you have to assume it. Okay, anyhow you have to assume it because you won't be able to solve the question, right? So based on these 4 points, I can say that this may be one of the hyperplane equation that is there. Okay, so try to get this concept. अगर कैसा question आया तो भैया आपको एक बार तो hyperplane की equation assume करनी ही पड़ेगी. You have to do this. So I would be assuming this, and which form? I would be taking this of the form weight transpose into X plus B, that is equals to 0. ठीक है, that is equals to 0. So this is the main hyperplane equation. I'll assume. Okay, अच्छा, अब इसके बाद if this is the main hyperplane equation, तो guys I hope you are able to actually identify that this could be one of the hyperplanes. This could be one of the hyperplanes. I hope you are able to get that. This could be one of the support vector planes. Okay, and this could be the second support vector plane. Okay, this could be the second support vector plane. Okay, so we have to draw it parallelly. So this could be one of the support vector plane and this could be the second support vector planes. Why? Because support vector plane passes through the support vectors. And what are support vectors? Support vectors are the nearest point to the hyperplane. Support vectors are the nearest point to the hyperplane. So guys, how many support vectors are there? I want answer from your side. How many support vectors are there? So if I'm assuming this as the main hyperplane equation, yes, how many support vectors are there? Very simple. So we have this as the support vector, we can consider this as the support vector, and we can consider this as the support vector. So that means if I assume this as the main hyperplane equation, so that means a total of 3 support vectors are visible. Okay, a total of 3 support vectors are visible. Okay, so a total of 3 support vectors are visible. So based on this data set, a total of 3 support vectors are there which are visible. I can't consider this as the support vector. I hope you are able to understand why this can't be considered as a support vector, because that is the farthest point from these two. That is not the nearest point. So you should remember the definition. What is a support vector? The nearest point from the main hyperplane equation. That is the support vector. So how many the class 1 support vectors? So we have 2 class 1 support vectors. So those are, this is a support vector, this is a support vector, and class 2 support vectors only a single one, that is 0, 0 based on this data set. So guys, if you just see, I think option B is correct. Based on this data set, okay, based on this data set, I think option B is correct. Number of support vectors are 3. So I think option B would be correct here. Okay, I think option B would be correct here. Okay, chalo. Now let us see the other options. What is the equation? Yeah, I want to ask you guys, what is the equation of this support vector? So weight transpose into x plus b, that would be equals to +1 if I consider this as the positive support vector plane, this class as positive. Okay, this I'm considering as the positive class. Okay, so I can consider this as the positive class and this as the negative class, and I can take that this would be weight transpose into x plus b, that would be equal to -1. You can change also, मतलब both the ways you can try, you will get the correct answer, क्योंकि आपको एक बार गलत मिल जाएगा, है ना, एक बार आपको गलत मिल जाएगा. ओके, see, Newsbuster, actually based on this data set, these 2 points are the nearest to this hyperplane. Okay, based on this data set, these 2 points are the nearest to this hyperplane. So I can say that these 2 are the 2 support vectors from class 1, and this is the nearest point because we only have 4 points in the data set. So based on this data set, I can say that 0, 0 may be the third support vector that belongs to class 2. So from these I can just make 2 planes, so positive support vector plane and negative support vector plane. Okay, I hope Newsbuster that is clear. So they would be parallel, no? So they have to be parallel because these planes are drawn parallel to the hyperplane. That is the property of this. Okay, चलिए अब यहाँ पर I am considering this as the positive support vector plane and this as the negative support vector plane. Okay, so if this is the positive support vector plane, so if I enter point 2, 0 here, okay, if I enter point 2, 0 here, okay, for 2, 0, okay, if I enter this point 2, 0, then this would be equals to what? This would be equals to +1. And if I enter point 0, 2, okay, if I enter point 0, 2, so that would be equals to what? That would be equals to +1. Okay, and next is what? Next point is 0, 0. Okay, next point is 0, 0. So if I if I take the third point, that is 0, 0 here, so that is very sure that I would be getting -1. Okay, so that means I have this as my first equation, this as my second equation, and this as my third equation. Okay, so I now have a total of 3 equations here. Very simple. Now you have to solve these 3 equations and you have to tell me the value of what? Tell me the value of weight and the constant. Tell me the value of weight and the constant. Okay, chaliye, now let us solve this. So weight transpose into x plus b, that is equals to 0. So I'll just consider weight coefficients are w1, w2. Okay, transpose into x. Okay, yes, and weight transpose into x, I'll consider independent variable, dependent variable plus bias equals to 0. So this would give me what? This would give me w1, w2, and here I have x and y plus bias equals to 0. Okay, so this is the main hyperplane equation. Okay, so w1x, w1x plus w2y plus bias, that is equals to 0. w1x plus w2y plus bias, that is equals to 0. So this is the main hyperplane equation. Okay, so from here, I can just write, from here I can just write that w1x plus w2y plus b equals to +1. Okay, for how many points? For 2 points. So this is for 2 points, 0, 2 and 2, 0. Okay, so I'll just put first point here. Okay, so yes, so this is for x. Okay, so and this that is for y. So 2w2 plus b, that is equals to 1. Then 2w1 plus b, that is equals to 1. Equation 1 and equation 2. Okay, and for the third one, w1 plus x1 plus w2y. Okay, w1 plus x1 plus w2y plus b, that is equals to -1. And this is for which point? This is for point 0, 0. So no worries, I'll just put I'll put this point here. So I would be getting bias equals to -1. Okay, I would be getting bias equals to -1. So yeah, so this is equation 3, no? This is equation 3. So I'll just put this here. So I would be getting 2w2 minus 1 equal to 1 and 2w1 minus 1 equals to 1. So what is w2 value? W2 value is how much? 2 by 2. And what is w1 value? W1 value is what? Again 2 by 2. So that would be equals to 1. So I'll be getting w1 1 and I'll be getting w2 equals to 1. Okay, so I'll be getting w2 1 and w1 equals to 1, and already I have bias equals to -1. Okay, that constant value is equals to -1, right? So if I check the constant value is coming equals to 1. If I check the constant value is coming equals to 1, so I think option A is wrong here. Okay, I think option A is wrong here. Okay, so and you can also verify by taking, yes, you can also verify this by taking this as the negative class and this as the positive class. Then also you will get a wrong option. Okay, then also you won't get option A. Then also you also won't get option A. So option A would be wrong here. Okay, so now let us calculate what? So now let us calculate what? Let us calculate the equation. Okay, the equation of the main hyperplane equation. So what is that equation? So weight transpose into x plus b equals to 0. Okay, or I can get w1x plus w2y plus b equals to 0. So what is w1? W1 is 1x1 plus x2, and what is bias? Bias is -1. Okay, or constant is -1. This is equals to 0. Okay, so this equation I am getting, right? This equation I am getting. Okay, so just calculate the margin here. Okay, calculate margin here. How to calculate margin? Very simple. Okay, how to calculate margin? Very simple. So margin for this equation, how to calculate margin? That is under root of a square no, just a second. Okay, calculate margin. No, how to calculate margin? Yeah, yes. So margin, the formula for margin would be 2 upon norm of W. Okay, I just forgot to tell you this. The formula for margin here, no, so this would be 2 upon norm of W. Okay, so just write the updated formula of margin. Okay, so formula of margin would be 2 upon norm of W. Okay, so that means 2 upon under root of W1 square plus W2 square. Okay, so this is the formula for margin. Okay, please everyone know, just write this, very important. I just forgot to tell you, this is the updated formula for margin in this case, in the vectorial form. Okay, so please everyone note it down, right? Everyone note it down. So this is the updated formula for margin in this case. Okay, 2 upon norm of W. Okay, I'll just tell you why that is 2 upon norm of W. I'll just tell you why. So since I have assumed this as weight transpose into X plus B equals to +1 and this is -1. So what is the distance here? I hope you are able to identify. What is the distance here? So this distance would be how much? This distance would be 2 upon norm of W. Okay, 2 upon norm of W. I hope you are able to guess this. Okay, Newsbuster. Yeah, why 2? I hope you are able to guess this, no? Ki this distance would be 2 because I've assumed weight transpose into X plus B equals to +1. For positive support vector, that is -1. So here margin would be 2 upon norm of vector. If at all you are not getting it, भाई by heart it. रट लो, question आना है. मुझे ऐसा लगता है question आना है, important है. नहीं भी समझ में आए, इसे रट लो, 2 upon norm of W. Okay, 2 upon norm of W. तो अब एक बार यही फॉर्मूला हम यहाँ पर यूज करते हैं. Let us use this formula. Okay, so now let us calculate margin here. So margin is what? 2 upon norm of W. Okay, so 2 upon under root 1 का square plus 1 का square plus 1 का square. So I would be getting root 2 as the answer. Okay, I would be getting root 2 as the answer. So what are the options here? What are the options here? Margin is root 2, B and C. Okay, so what are the options? B and C. Option D is just absurd. Training accuracy 98%. कोई मतलब ही नहीं हुआ इसका. क्या मतलब है? कुछ भी नहीं है. Okay, that is just an absurd option. D is just absurd. Okay, so option B and option C, these two are the correct options for GATE 2025. 2-mark question. Okay, 2-mark question. So option B and C are the correct one. I hope you are able to judge the difficulty level what GATE is asking. I hope आप समझ पा रहे हैं, you are able to judge the difficulty level of what GATE is asking. तो SVM entirely depends on your concepts. अगर आपका concept clear है, easily निकाल दोगे, और कुछ भी नहीं है बच्चा. अगर आपका concept clear है, आप निकाल दोगे. ठीक है? तो option B and C. Yes, Newsbuster will do this. No, what is FX and what is hard margin? I'll just let you know. Okay, very important. बहुत important concept है. Hard margin का भी और इसका भी बहुत important concept है. We'll do this. Just wait for a few minutes. Okay. Yes, Teja, accuracy is just absurd. No, there is no, I mean, we can't find accuracy this way. Okay, we'll find accuracy in remaining questions I have, but ये जो इसने दे रखा है ना, here the question that is given, no, कि accuracy of training is 98%. So here we can't find the accuracy. Okay, data is incomplete. So I'll just give you certain other questions where you can find the accuracy. Okay. Okay, chaliye now solve certain other questions. Okay, try to solve this question. Yes, yes, Newsbuster, just don't worry. We have a separate session on PYQ. Okay, so I'll be taking this. Just don't worry. We'll be having number of sessions. Okay, I just need your support. Just share it as much as possible. I'll be taking it, बच्चा. Just don't worry. मेरे पास काफी सारे questions है. I'll be doing this. Okay, chali, how to solve this? See, we have this equation. Okay, I have this equation of main hyperplane. Okay, so now what I have to do is, this main hyperplane equation is there. Now what I have to do is calculate the distance between the following points from the hyperplane and also classify data points as positive and negative. Okay, तो देखो सबसे पहले तो what you have to do is you have to calculate distance of that point from the hyperplane and classify whether these points are positive or negative. Okay, classify. Yeah, Veda, just don't worry, beta, we'll do this. Just don't worry. I have number of questions. No, I'll give you for homework as well. Okay, so now here we have certain points. We have to classify these points as positive or negative. Okay, so how to do this? Now how to do this? Okay, so this is the main hyperplane equation. So very simple. I have given you the concept. No, what is the concept? For example, I have only a single independent variable and a dependent variable. This is the main hyperplane equation, that is negative of 0.5 x1 plus 0.5 x2 plus 0.5, that is equals to 0. Okay, now I need to identify whether this is negative class or positive class. So firstly what I'll do is I'll just put 0.7 comma 4. Okay, I'll just put 0.7 comma 4. So negative of point x1 is what? 7. Okay, and yeah and we have the second point as 4. So 0.4 into x2 is what? X2 is 4. Okay, plus 0.5. So just calculate this, how much it is coming. Is it coming positive or negative? Okay, and for 8 comma minus 4. Just calculate this. Negative of 0.5 into 8. Negative of 0.5 into 8 plus 0.5 into negative of 4. Zero 0.5 into negative of 4 plus 0.5. So 7 comma 4, yes, so we would be getting negative 1 and 5.5. okay, so we would be getting negative 1 and 5.5. okay, negative 1 and negative of 5.5. yeah, we'll be getting negative of 5.5, negative 1 and negative of 5.5. so that means both of the point, that means both the points. okay, what does that mean? Both the points belongs to belongs to negative class. okay, that means both the point belong to the same class. okay, that means both the points belongs to the negative class. okay, acha, ab now for example we have this point, for example we have this point 7 comma 4. okay, this point is 7 comma 4 and yeah, this point is 8 comma minus 4. okay, for example we have this point as 8 comma minus 4. so now what he is asking this distance. okay, he is asking this distance. Though you have studied it number of times, okay, though you have studied it number of times, but still how to calculate distance, I'll just tell you very simple formula. आपको आता है, already you know it. okay, you have studied this in maths, but still I'll just tell you how to calculate it. So distance is calculated by distance of any point. okay, how to calculate this? You just put that point, put the point a x1, for example distance of x1 y1, so a x1 plus b y1 plus c upon under root of a square plus b square. okay, so for example 7 comma 4, so I'll just put this 7 comma 4 in this plane. okay, so already you know it, just revise these concepts, right? so that would be negative of 0.5. yeah, so 7 comma 4, so the value is minus 1 upon under root of a square plus b square. okay, and what is a is negative of 0.5 ka square plus 0.5 ka square. so this is distance of what? Distance of point 7 comma 4. okay, and distance of point 8 comma minus 4, already you know this. okay, just for your revision, so that would be how much? ax2 plus by2. this point is negative of 5.5 upon under root of negative of 0.5 ka square plus 0.5 ka square. okay, and apply a mod here. okay, just apply a mod here, because distance, when you are giving the answer in the NAT type questions, no, distance would never be negative. I hope you are getting this too. Distance you will always be giving this in the positive form only. okay, so for example this is x1, this is distance 1. yeah, this is distance 1. okay, this is d1, this is d1, this is d2. okay, so just calculate the values of d1 and d2, everyone. okay, so you will be getting 1.414 and 7.778. okay, so this is 1.414. okay, This distance is how much? 1.414, and second would be 7.778. 7.778. Okay, so these are the distances. Okay, so it is preferred that always use a mod here in the numerator because distances are never given in the negative format, but still depends on the question. एक बार देख लेना, थोड़ा दिमाग वहाँ पर apply आपको करना है. Okay, in the gate you have to apply your logic there, no, कि what exactly he is asking. Yes, what is the margin of separation? Last question is what is the margin in this SVM model? Yeah, what is the margin in this SVM model? Yeah, last question. What is the margin? What is the margin? हाँ, वही Uddhav, generally we just write these in the positive format. Okay, distance are generally written in the positive format. Okay, but still depends on the question. वो sign के साथ मांग रहा है कि sign के बिना मांग रहा है, that depends. Okay, तो just don't worry, वो देख लेना एक बार question में कैसे मांग रहा है आपको ना, तो उस हिसाब से आप करना है आपको. ठीक है, चलो अब now what is the margin? Very simple. How to calculate margin? तो margin is nothing, that is margin is 2 upon norm of weight vector. Okay, margin is 2 upon norm of weight vector. Okay, and what is weight vector here? So what is weight vector here? So here, what is weight vector? So I would be considering negative of 0.5, positive of 0.5 as the coefficient. Okay, negative of 0.5 and positive of 0.5 as the coefficient, because you know that, don't get confused. Okay, because you know weight transpose into x plus b, that is equals to 0. Okay, and what is weight transpose into x plus b? Okay, what is weight transpose into x plus b? So that is w1 and w2. Okay, that is w1 and w2. So weight transpose into x, what is that? Okay, that is nothing, that is w1 and w2. And what is x? X is x and y plus b equals to 0. So that means w1x plus w2y plus b equals to 0. So here it is given negative of 0.5x1, negative of 0.5x1, okay, plus positive of 0.5x2. So positive of 0.5x2 plus 0.5 equals to 0. Plus 0.5 equals to 0. So here I would be just, what I'll do is I would be just equating these two. Okay, because this is the best information which I have. This is the best information which I have. Okay, okay. So this is the best information which I have. So I would be just updating this. No. So what is, yeah, what is W1? So W1 I can just write it as okay. So this is W1. And this is W2. ठीक है, and this is bias. So I can write under root of negative 0.5 का square plus positive 0.5 का square. Okay, so this is the best information which I have. Okay, so you would be getting, yeah, 2.824. Okay, so this is 2.824. ठीक है, तो ये आपको इस तरीके से करना है. Okay, चलिए, one last question from my side on this concept. Okay, yes, so this question actually would test you the concept of evaluation matrix along with the support vector field. Very good question. Okay, I would just rate it as a very good question. It would actually test the concepts of support vector machine along with the evaluation matrix. Okay, so how to solve this question? So we are given with this main hyperplane equation. Okay, this is the main hyperplane equation that is given. Now what we have to do is we have to calculate the precision of the positive class, recall of the negative class, and accuracy. Okay, I think one of you were asking, sir, how to calculate accuracy. See here, you will be getting it. How to calculate accuracy, you will be getting it here. Okay, तो आप देखो, तो here the concept of the support vector machine and along with this the evaluation matrix that is given. So we have two predictors here. Okay, we have two predictors here, two features, right? So we have two features and this is the actual class. Okay, this is the actual class. I hope you are getting this. अब हमको क्या करना है, ये कह रहा है, he is saying that this model is trained with what? It is trained with SVM learning algorithm. Okay, this model is trained with what? It is trained with SVM learning algorithm. Now what does he say? He says that calculate the precision of the positive class, recall of negative and accuracy. तो अब उसके लिए सबसे पहले what we have to do is, उसके लिए what we have to do is we have to calculate the prediction using SVM algorithm. We have to calculate the prediction using SVM algorithm. अब अगर मान लीजिए, just for an example, if it was a logistic regression model, तो कैसे करते? How you would have solved it? You would have used a sigmoid function और वहां से आप निकाल लेते what is the probability और वहां से आप prediction निकाल लेते, right? I hope you are getting this, no? If it would have been a logistic regression question, then you would have used sigmoid function and then you have calculated the probability and other things, okay, other prediction. But this is what? This is the SVM algorithm question. तो भैया simple है, SVM algorithm question very simple. How to do this? For SVM you just put this point in this hyperplane equation. You know this. You put all these points in the hyperplane equation. This point here, this point in this hyperplane equation, all the points in this hyperplane equation, and based on the positive and negative what you are getting, you can actually predict whether this is a positive, whether it belongs to positive class or negative class. Very simple. Okay, so if I just take point number 1, no, if I just take point number 1, so that means negative of 0.5 x1 plus positive of 0.5 x2 plus 0.5. For what? For point number, yeah, for sample 1. Sample 1 is what? For 1,5. Okay, sample 1 is what? 1,5. So I'll just put this point here. Negative of 0.1 into x11. Okay, plus 0.5 into x2. What is x2? x2 is 5 and plus 0.5. So this would be how much? Is it positive or negative? Yes. Complete the table. So it is very clear. I would get a positive value here. So that means, okay, so that means what is the prediction using SVM algorithm? What is the prediction using SVM algorithm? The first point prediction using SVM algorithm is what? That is positive. Okay, similarly check for the other points. So this would come positive, this would come negative. Okay, but you check it. Okay, you check it. I am writing because I have my the results written over here, but you check it. Then positive, negative, positive. Then I have positive, negative and positive. Okay, positive, negative, positive, and yeah, last two are negative, negative. Last two are negative and negative. So guys, please check it. Okay. Okay, now what we have to do, we have to find the precision. Okay, for finding the precision and recall, I always say that make the confusion matrix. Okay, I would always say that make a confusion matrix. ठीक है, make a confusion matrix. Now for making the confusion matrix, I'll write actual class on the top and I would write predicted class on the left hand side. Okay, and yeah, so I'll just write positive actual and positive predicted, then negative actual and negative predicted. Okay, I'm just making a 2x2 confusion matrix. I hope you're able to understand. No, I'm making a 2x2 confusion matrix. Now let us check true positives. How many true positives are there? Actual positive, predicted positive. Okay, so that is how many of those are there? So actual positive, predicted positive, 1, then 2, then 3. Okay, so we have a total of 3 true positives. I hope you are getting this. I have a total of 3 true positives. Then what are true negatives? Actual negative, predicted negative. We have 1, yeah, we have 2, and we have 3. Yes, we have 3. So we have a total of 3 true negatives. Okay, yeah, so we have a total of 3 true negatives. Okay, we have a total of 3 true negatives. Now false positives. How many false positives? So false positives are actually negative but predicted positive. Actually negative, predicted positive. So this is false positive, 1 false positive and 1 false negative. Okay, 1 false positive and 1 false negative. Now we need to predict what? We need to predict the precision. Okay, we need to predict what? We need to predict the precision of the positive class. So true positives upon the total. Okay, total predicted positive, that is 3 plus 1. So that means 3 by 4. 0.75 is the answer. Okay, for precision of the positive class. Okay, then recall. Guys, just see here, recall of what? Very important, very tricky question. Recall of negative class. Guys, very tricky question. Okay, very tricky question. Recall of what? Recall of negative class. बेटा बहुत important question है, यहाँ पर आधे बच्चे गलत करेंगे. Okay, majority of you would make this wrong. See, what exactly is the recall of positive class? First, let me know what is the recall of positive class. How to calculate recall of positive class? So for calculating the recall of positive class, what is the formula? True positive upon. True positive upon what? True positive upon actual positives. True positives upon actual positives. This is the I mean a recall of positive class. Okay, but for calculating the recall of negative class, so what is the recall of negative class? So recall of negative class would be what? This would be true negative upon. I hope you are getting this. This would be how much? This would be true negative upon the total column. Okay, that is true negative plus false positive. Okay, so guys, very important, just you have to understand this concept. He says recall of negative class. Beta, this is negative class, just don't get confused. Okay, so recall of negative class means we have to take true negatives, not true positives, because that is the recall of positive class. True positive upon actual positives. Here true negatives upon actual negatives. I hope you are getting this. So that means what is the recall of negative class? Part B. Recall of negative class. Recall of negative class is how much? That is true negative upon true negative plus false positive. So that means it is 3 upon 3 plus 1. Answer won't change, but concept should be clear. Okay, answer shouldn't change. Yeah, answer won't change, but concept should be clear. So recall is also 0.75. Okay, recall is also 0.75. Okay, and C part is what? C part is accuracy. Okay, C part is accuracy. So that is very simple. True positive plus true negative upon true positive plus true negative plus false positive plus false negative. So what is true positive? 3 plus 3, 6. Okay, and yeah, so true positive plus false negative plus true negatives. Okay, so that would be how much? 6 upon 8. ठीक है, आई होप दिस थिंग इज क्लियर. आपको समझ में आया होगा कि what exactly the concept is. That is mixing what? Support vector machine along with the क्लासिफिकेशन मैट्रिक्स। ठीक है बच्चा, तो ये इंपॉर्टेंट है, आपको समझना है। ओके चलिए, अब नाउ वी आर लेफ्ट विद टू मोर कॉन्सेप्ट्स। आई टेक वन मोर 10 minutes break. Okay, yeah, I'll take one more 10 minutes break, but don't go. Okay, please don't go. We'll be covering that. Okay, I'll just take a 10 minutes break. एक बार मैं पानी पी लूँ, then let us again meet at one close to 1:30, and we'll have one more 1 hour more class. Okay, so please don't go. I just request everyone till 2:30 we'll be taking it, right? So I'll be taking one more 15 minutes break. Okay, we'll meet at 1:30 p.m. Okay, please don't go. We have to cover two more important concepts, right? I request everyone, please don't go.
Okay, welcome back. Now let us start with the new topic now in the support vector machine. Okay, that is that is the concept of slack variable. Okay, very important. Now let us start with the new topic here. Yeah, that is the concept of slack variable. Okay. Yeah, so now I'll start with one new topic, that is the concept of slack variable. Okay, so that is the concept of slack variable. Okay, yes. So see what exactly slack variable is. Slack variable is introduced to actually allow or to determine that whether we have a misclassification or not. Okay, so we have introduced this to determine whether we have misclassifications in the support vector machine algorithm or not. Okay, for example, this is independent variable x and this is the dependent variable y. Okay, for example, we have this as the independent variable and y as the dependent variable. Okay, and I am drawing I'm drawing a support vector, I'm drawing a hyperplane equation. Okay, and for example, this is positive support vector and this is a negative support vector. Okay, this is positive support vector and this is negative support vector. So positive support vector passes through positive data points and negative support vector passes through negative data points. Okay, positive support vector passes through positive data points and negative support vector passes through negative data points. Okay, so I'll just write that this equation weight transpose into x plus b, that is equals to 0. This is weight transpose into x plus b, that is equals to -1, and here weight transpose plus x into b, that is equals to +1. Okay, so this is the graphical scenario for a support vector machine algorithm. Right now I need to check whether we have misclassifications or not. Okay, I need to check whether we have misclassifications or not. So for example, this is a misclassification here. Okay, and we have here a misclassification, right? So for example, I have two misclassifications here. Okay, so one on the positive side and one on the negative side. Okay, one on the positive side and one on the negative side. Now I would introduce a slack variable here. अब मैं क्या करूंगा, मैं एक slack variable को introduce करता हूं. Okay, I would introduce a slack variable here. That distance, or yeah, the name of that slack variable is epsilon. Okay, the name of the slack variable is epsilon, right? So I can just say that if epsilon is less than equals to d plus or d minus. Okay, and I'll just again make you revise what is d plus. This is d plus. Okay, this is positive distance of support vector plane from hyperplane, and this is the negative. Okay, d minus is the negative margin, right? And that is the positive margin of separation. This is the negative margin of separation. So now what I have done is I have introduced a slack variable. Okay, that actually checks whether there is a misclassification or not. अच्छा, अब यहाँ पर see the concept. Okay, just see the concept. If epsilon, okay, slack variable is known by the term epsilon, right? So if epsilon is less than equals to d plus or d minus, that means the correct the point is correctly classified. Okay, so what does that means? It means the point is correctly classified. Okay, what does that means? The point is correctly classified. And if epsilon is greater than d plus or d minus, तो इसका मतलब क्या हो जाएगा कि point is wrongly classified. Okay, या फिर misprediction is there. Okay, point is wrongly classified, or I can say we have a misprediction. Okay, point is wrongly classified, or we can say that we have a misprediction. Okay, so अब now for positive point I would be drawing this slack variable from the positive support vector plane, and for a negative point I would be drawing this the slack variable from the negative support vector plane. That you have to remember. Okay, this you have to remember. तो positive के लिए आप positive से बनाओगे, negative के लिए you would draw from negative. Okay, तो this you have to remember. Okay, this you have to remember. So very important concept of slack variable. So if it is greater than d plus or d minus, that means the point is wrongly classified or it is misclassified. Okay, else the points are correctly classified, correctly predicted. Okay, points are correctly predicted. Okay, just draw this. Okay, now based on this concept, I would be defining a hard margin soft vector machine, support vector machine. Okay, based on this concept, I would be defining a hard margin support vector machine. Okay, based on this concept, I would be defining a hard margin support vector machine. Okay, so hard margin support vector machine, it for a linearly separable data. Okay, yeah, so I'll just write the definition. For a linearly separable data, okay, for a linearly separable data, the goal is to find the hyperplane that maximizes. Okay, what is the goal? The goal is to find the hyperplane, okay, that maximizes what? Maximizes margin. Okay, that maximizes the margin between the two classes, maximizes the margin between the two classes. अब जो information आएगी, while ensuring that all the points are correctly classified. Okay, very important. While ensuring that all the points are correctly classified. Okay, very important. While ensuring that all the points are correctly classified. Okay, while ensuring that all the points are correctly classified. तो the hard margin support vector doesn't allow, आप समझिएगा. Okay, just try to understand the concept. The hard margin support vector never allows for any misclassification. Okay, the hard margin support vector never allows for any misclassification. तो अब जैसे for example if at all any misclassification would be there, मान लीजिए अगर कोई misclassification होगा तो it would try to minimize the margin. मतलब वो क्या करेगा, कहेगा भाई मैं allow नहीं कर सकता, तुम भले ही margin को कम कर दो but मैं किसी भी misprediction को allow नहीं करूंगा. Okay, so this is the concept of negative हार्ड मार्जिन सपोर्ट वेक्टर मशीन. ओके, दिस इज द कॉन्सेप्ट ऑफ हार्ड मार्जिन सपोर्ट वेक्टर मशीन. वो क्या बोलेगा, वो ये कहता है कि भैया मैं किसी भी मिस प्रेडिक्शन को अलाउ नहीं करूंगा. आई वोंट बी अलाउइंग any misprediction. Okay, so what I do is, okay, let it be that the margin is reduced. No worries, कोई बात नहीं, कोई बात नहीं. Let it be the margin is reduced, but I won't be allowing any misprediction that can occur. Every point would be correctly predicted. Okay, so in this case the accuracy of the algorithm would increase, but here the overfitting chances would also increase. क्योंकि भाई he would see, no algorithm is 100% accurate, no algorithm is 100% accurate, but he says कि भैया मैं तो कुछ ऐसा कर दूंगा कि no worries, I can just reduce this I mean the margin, but I won't be allowing any misclassification. Okay, so that is why it is an ideal concept. Okay, because we can't have such practically possible algorithms. Okay, so that is a concept that is ideal. Okay, so it says that I won't be allowing any misclassification here. Okay, let it be that you just reduce the margin, कुछ भी कर लो, but मैं होने नहीं दूंगा. Okay, so for that case, okay, so in that case if mathematically I want to present, so in that case mathematically margin is what? Okay, for this case what is the margin? 2 upon norm of vector. Okay, for a hard margin support vector we have margin is defined as 2 upon norm of vector. Okay, hard margin is defined as 2 upon norm of vector. Okay, that is defined as 2 upon norm of vector. And what is the objective function? What is the objective function? Objective function is, okay, just write the objective function. What is the objective function? It is half of norm of weight vector square subjected to the constraint. Okay, subjected to, so this is the objective function. You have to remember it. Okay, ये आपको याद रखना है. Okay, this you have to remember this. Okay, subjected to the constraint yi into should be always greater equals to 0. Yi into weight transpose into xi, yi into weight transpose into xi. Okay, yi into, yes, weight transpose into xi. Yi into weight transpose into xi, that should be greater or equal to 0 for I equals to, what is I? For I that belongs to real number. Okay, for I that belongs to real number. So I equals to 1 2 3 4 till number of data points. Okay, so I'll just write I belongs to real number, or I'll just write 1 2 3 kab tak, till number of data points that are there in the data set. Okay, that are there in the data set, and we try to minimize the objective function. Okay, and we always try to minimize this objective function. Okay, so you just remember this, we try to minimize this objective function is minimized. Okay, so this is how mathematically we present a hard margin support vector machine. Okay, this is how mathematically we present hard margin support vector machine, where what is yi? Yi is the actual class. Okay, where what is yi? It is the actual class. What is xi? Yeah, what is xi? तो xi जो आ जाएगा data points. Okay, data points. Xi is the data, xi are the data points, x1 x2 x3 x4. Okay, these are the data points, या फिर I would better say these are the features. ये आप ये ऐसा कह लो, ये features है. Okay, these are the features, not data points. I would say these are the features, x1 x2 x3 जितने भी features हैं. Okay, these are the features. Okay, these are the features, या फिर feature vector, because vector की terms में कर रहे हैं तो हम इसको feature vector भी बोल सकते हैं. Okay, this is the correct one, feature vector. And what is n? N is the total samples. Okay, what is n? N is the total number of samples. Okay, n are the total number of samples. ओके, another total number of samples. तो अब आप किसी भी पॉइंट को उठा लीजिए, you just pick any point randomly, you just put this ith point here and along with this class, along with that point's class, you would be always getting greater equal to 0 because every point is correctly classified. Okay, just try to understand this. What I have done is I would be putting all the points all the points here, and I would be putting the class also. For example, I have sample 1. Okay, just for an example, okay, for example, yeah, so for example I have yes, for example I have two feature vector x1, x2 and y. So for 1 and 3 class is 1. Okay, for feature vector 2 and 5 class is -1. For feature vector 3 and 6 class is again 1. So what I would do is if I put point here जैसे yi into, yeah, so this is the constraint. Okay, so yi into weight transpose into xi plus b, this would be always greater equal to 0. So if I put any point, no, if I put a point 1, point 2, point 3 here, so this condition would be true for every point. Why? Because hard margin says कि भैया मैं कोई सा भी misclassification allow नहीं करूंगा. तो generally you would be getting certain questions जहां पर आपको misclassification generally allow नहीं होगा. Okay, you would be getting certain questions जहां पर वो खुद ही बोलेगा. Question would say it is a hard margin support vector machine. Okay, he would say what is this is a hard margin support vector machine, मतलब कोई भी misprediction नहीं है यहाँ पे, there is no misprediction. Okay, तो hard margin support vector is margin is ये हो गया, objective function is this, we have to minimize this, and that is subjective नहीं, subjected होगा, sorry, this is subjected. Okay, yeah, this is subjected to the constraint. What is the constraint? This is the constraint. Okay, what is the constraint? This is the constraint. Subjected to the constraint, yeah, so this is the constraint. Okay, so you have to memorize this. Okay, certain points you have to memorize this hard margin support vector machine, and I'll tell you soft margin also. Okay, I'll tell you soft margin support vector machine. Okay, I'll wait for a minute, just write it. Yeah, objective function is newsbuster. Objective function is the cost function, no? It is like the cost function. Okay, जैसे what was the cost function in case of linear regression? That was MSC. Okay, so similarly here it is the objective function is half of norm of weight vector square. Okay, so this you have to actually memorize. Okay, ये आपको याद ही रखना पड़ेगा. There is no other way of writing memorizing it. Okay, up now I would show you what soft margin support vector machine is. Okay, just try to make note of it, no, कि what exactly soft margin support vector machine is. So I'll just try. Soft margin support vector machine. Okay, soft margin support vector machine, yeah, soft margin support vector machine. So here it yeah, in the presence of non-separable data. Okay, I'll start with this point. In the presence of non-separable data. Okay, in the presence of non-separable data, the support vector, the model allows for some misclassifications. Okay, the model allows for some misclassifications. the model allows for some misclassifications introduced by slack variable. Introduced by slack variable. ठीक है, तो अब द मेजर कॉन्सेप्ट ऑफ दिस सपोर्ट वेक्टर मशीन इज कि यार ही नोस, देखो भाई ऐसी कोई भी दुनिया में एल्गोरिथम नहीं है, देयर इज नो एल्गोरिथम इन दिस यूनिवर्स विच इज 100% करेक्ट फॉर एवरी डेटा पॉइंट. ओके, वी कांट गेट दैट. तो ही सेज व्हाई टू मेक दैट मार्जिन सो मच नैरो. भाई मैं इतनी नैरो क्यों करूं, मैं कह देता हूं ना यार कि कुछ मिसप्रेडिक्शंस हो गए, आई जस्ट अज्यूम कि कुछ मिसप्रेडिक्शंस हो गए, भाई भाड़ में जाए होते हैं होए, बिकॉज नो एल्गोरिथम इज 100% एक्यूरेट. सो ही सेज भाई ऐसा करते हैं कि मैं तो क्या करूंगा, व्हाट आई विल डू इज आई वुड ट्राई टू मैक्सिमाइज दिस. मैं क्या करूंगा, इसको मैं मैक्सिमाइज करता हूं, बिकॉज एज मच आई विल बी एबल टू मैक्सिमाइज इट. तो बेसिकली व्हाट एडवांटेज आई वुड बी गेटिंग, इसके बीच में कुछ भी भसड़ होगी दैट आई कैन इजिली बी एबल टू रेक्टिफाई इट. जितना ज्यादा मैक्सिमाइज कर पाऊंगा, जितना ज्यादा मैक्सिमाइज करूंगा, तो इसके बीच में अगर कोई भी भसड़ होगी तो दैट आई वुड बी एबल टू रेक्टिफाई इट. तो वो कहता है ठीक है यार, लेट इट बी, ओके सर्टेन पॉइंट्स आर मिसक्लासिफाइड, ओके लेट देम बी मिसक्लासिफाइड. स्लैक वेरिएबल बता देगा कि दीस पॉइंट्स आर मिसक्लासिफाइड, एक्यूरेसी इज लेस, प्रिसिशन इज देयर, रिकॉल इज देयर, ओके नो वरीज. ही सेज but okay, the overall accuracy, overall performance would be increased no if I try to maximize this. अगर मैं इसको मैक्सिमाइज करता हूं और कुछ मिसक्लासिफिकेशंस आ भी रहे, क्योंकि यार देखो डेटा हो गया टेढ़ा मेढ़ा, डेटा होता है भाई, अनशंट डेटा होता है. तो अगर मान लो कहीं आउटलायर्स हैं, नॉन लीनियरली सेपरेबल डेटा है, साला एक्सपोनेंशियल की फॉर्म में बैठा हुआ डेटा, अबे तुम कहां से कर पाओगे उसको, पूरा आप सेपरेट नहीं कर सकते. तो ये क्या करता है, ही सेज कि अगर जो भी तरीके का डेटा होगा जो मुझे मिलेगा अनसीन डेटा, अब जैसे फॉर एग्जांपल वी हैव अ डेटा फॉर आईपीएल, ठीक है, आई हैव अ डेटा फॉर आईपीएल, तो 80-90% डेटा वुड बी दी तरीके का डेटा मतलब दैट वुड बी लीनियरली सेपरेबल, और वी डोंट हैव एनी आउटलायर्स और वी डोंट हैव एनी नॉइस. तो सच सॉर्ट ऑफ थिंग्स आर देयर इन दी 80-85% डेटा. 15% डेटा ऐसा है कि साला इसको मैं कर ही नहीं सकता सेपरेट, बिकॉज दैट इज ईदर वी इट इज ऑफ द एक्सपोनेंशियल फॉर्म, लॉगरिथमिक फॉर्म में है, या फिर कुछ ऐसा है कि आउटलायर्स है, अनशंट डेटा है. तो वो कहता है भाई फॉर दैट डेटा यूज अ सॉफ्ट मार्जिन एसवीएम. ओके, तो दैट डेटा आई क्या कहते हैं, एक्सेप्ट दैट आई कांट लीनियर, आई कांट सेपरेट दैट डेटा, नो वरीज, स्लैक वेरिएबल वुड टेक केयर ऑफ इट, और वो बता देगा भैया दीज ऑल आर मिसप्रेडिक्शन. तो कहता है ठीक है भाई भाड़ में जाए, बट फॉर द अनसीन तरीके का डेटा एटलीस्ट माई मॉडल वुड बी वेरी एक्यूरेट फॉर दैट. तो बेसिकली उस कॉन्सेप्ट को लेके, फॉर दैट कॉन्सेप्ट द सॉफ्ट मार्जिन सपोर्ट वेक्टर मशीन हैज बीन डिजाइंड. तो दिस इज द कॉन्सेप्ट व्हाई सॉफ्ट मार्जिन सपोर्ट वेक्टर मशीन हैज बीन डिजाइंड. ओके, तो अब जैसे अगर मान लीजिए मैथमेटिकली आई नीड टू प्रेजेंट, ओके मैथमेटिकली इफ आई नीड टू प्रेजेंट, तो मैथमेटिकली वुड बी व्हाट वुड बी द ऑब्जेक्टिव फंक्शन, व्हाट वुड बी द ऑब्जेक्टिव फंक्शन. तो व्हाट इज द ऑब्जेक्टिव फंक्शन, दैट इज हाफ ऑफ नॉर्म ऑफ वेट वेक्टर का स्क्वायर. ओके, दैट इज हाफ ऑफ नॉर्म ऑफ वेट वेक्टर का स्क्वायर प्लस, अब यहां पर क्या करेगा, एक ये पेनल्टी टर्म डाल देगा, ये कुछ नहीं करेगा, ये कह रहा है कि भाई तुम ठीक है, दैट वाज द ऑब्जेक्टिव फंक्शन दैट आई हैव टू मिनिमाइज, नाउ जस्ट ऐड अ पेनल्टी टर्म हियर सी. ओके, सी अपसाइलन या सी समेशन आई इक्वल्स टू 1 to n एंड अपसाइलन आई का मॉड. ओके, दिस इज द ऑब्जेक्टिव फंक्शन. ठीक है भाई, दिस इज द ऑब्जेक्टिव फंक्शन. तो ये है ऑब्जेक्टिव फंक्शन यहां पे. Okay, this is the objective function. Okay, so what is half of norm vector square plus c times I equals to 1 to n epsilon I का mod. Okay, where what is epsilon I? What is epsilon I? I hope you remember. See, this is if you just combine this whole term, no, if you just combine this whole term, okay, so I would say this is known as penalty. इसको हम क्या बोलते हैं, इसको बोलते हैं penalty term. Okay, and what is c? C is regularization parameter. Okay, I'll just write what is c. C is a regularization parameter. Okay, C is a regularization parameter that actually controls the trade-off between margin maximization and penalty for misclassification. Okay, very important, that controls that controls the trade-off, between margin maximization. Okay, that controls the trade-off between margin maximization and और क्या था ये penalty for misclassification. ठीक है, and penalty for misclassification. ठीक है, for misclassification. Okay, penalty for misclassification. What is epsilon? I hope you know, everyone knows this, no? So what this I hope everyone knows this. So what is epsilon? Epsilon is the slack variable. Okay, so epsilon is the slack variable. Okay, so this whole term is known as penalty. Okay, this whole term is known as penalty. Okay, but objective function is added with this slack variable mod into C, that is regression parameter. So basically this we have to minimize. Okay, objective function anyhow we have to minimize this. Okay, we have to minimize the objective function, but here this penalty term is added because वो कहता है कि भाई अनशन डेटा को मैं ज़्यादा जो टेंशन नहीं लेने वाला अनशन डेटा की, वो कहता है भाड़ में जाए भाई, अगर नहीं लीनियरली सेपरेबल हो पा रहा मैं क्यों टेंशन लूँ, गलत है तो गलत ही सही. तो फॉर दैट this penalty term is added. I hope you are getting this. Okay, and yeah, what is n? N, I hope you are able to see. N is the total data. Okay, data points, total data points. So this is how objective function is defined. Okay, this is how objective function is defined and subjected to the constraint. Okay, this objective function subjected to the constraint. So we have a constraint also. Okay, subjected to the constraint. Subjected to the constraint. This objective function is subjected to the constraint yi into weight transfer into xi plus b, that is greater or equal to 1 minus epsilon I. Okay, so this is the constraint that support vector machine has for a soft margin support vector machine. Okay, so for a soft margin support vector machine, this is the constraint. Okay, so it allows for certain misclassification. So I'll just write it here, very simple, very important, that this actually allows for certain misclassification. It allows for some misclassification introduced by slack variable. Okay, this is the important point. Yeah, constraint part very simple, no? See, actually here we had this constraint. Constraint part was what? That it is constraint to 2 upon, it's a margin is 2 upon norm of vector w, objective function is this, and it is subjected to constraint this. So hard margin क्या बोला? Hard margin says कि I want that every data point should be correctly classified. So if you just put all the data points here, no, so these data points would be correctly classified here. Okay, if you just put all the data points here, so this would be correctly classified. Okay, yeah, this is greater or equal to 1, not 0. This is greater or equal to 1. Yeah, this is greater or equal to 1. Wrongly I've written that. Okay, here also I think 0 लिखा है कि 1 लिखा है. यहाँ पे भी 0, अच्छा 1 होगा. बेटा ये correct कर लेना. Sorry, wrongly I've written. This is 1. Okay, please write this. This is 1. ठीक है, 0 नहीं है, ये 1 है. Okay, तो please correct this. Okay, this is not 0, this is 1. तो अब what he says कि आप class label को डालो and you just put class label here. What is class label? For example, for first point, this is point 1. Okay, this is point 1, this is point 2, this is point 3. So for first point, and if I put the class label here, class label into first point, so I would be always getting greater equal to 1. This is for what? This is for hard margin support vector machine. Okay, this is for hard margin support vector machine, hard margin SVM. Okay, this is for hard margin SVM. But for soft margin, if you put, so this condition may be violated. Okay, for soft margin SVM, okay, for soft margin SVM, if you put, so this condition may be violated. So what he says, कि he just change this to 1 minus epsilon I. Okay, so if you put all these points here, so this condition may be violated. So what did soft margin support vector machine did? So if you put 0.1, so it would be added with its slack variable for 0.1. Okay, I'll just write this for 0.1. Okay, for sample, for data 1. Yeah, for sample 1. Okay, for sample 1. So I would just put yi. What is yi? Yi is 1 into what is weight transpose, for example, weight transpose is w1 w2. Okay, and what is xi? Xi is x1 x2. Okay. Okay, and plus b. So this would be greater equal to 1 minus epsilon 1 for first sample. Okay, so this is how condition would change. So similarly, it would change for condition it would change. I mean, for sample 2 also, I would just put 1 minus epsilon 2. For 3, I would put 1 minus epsilon 3. So this is how condition would change for soft margin SVM, and these are the conditions for a hard margin SVM. Okay, guys, these are the conditions for hard margin SVM. So bus, you have to remember that hard margin doesn't allow for misclassification. This is the mathematical formulation for hard margin for hard margin support vector. This is the mathematical formulation for hard margin support vector. And soft margin support vector, what does a soft margin support vector do? It allows for certain misclassifications by introducing a slack variable here, So that means he says कि भैया ये वाली जो condition है तुम्हारी, ये violate हो सकती है. कौन सी वाली? ये वाली जो condition है, ये violate हो सकती है. तो he said what, कि उसने कहा भैया ऐसा करो ना, एक slack variable को minus कर दो, तो condition violate होगी तो at least वो slack variable यहाँ पर बचा लेगा. I hope you are getting this. तो बस वही चीज यहाँ पर हमने करवाई है for soft margin support vector. और mathematically अगर आपको देखना है, mathematically भाई आप यहाँ से इसको याद रखो. Mathematically you should remember this way. Okay, so please write this in 2 pages. Okay, staple 2 to 3 pages specifically for SVM. ठीक है, तो वो आपको थोड़ा सा यहाँ पे लिखना पड़ेगा. ठीक है, चलिए अब गेट 2024 का क्वेश्चन है. सपोर्ट वेक्टर मशीन क्वेश्चन वाज देयर फॉर 2024. गाइस एक बार कर लो फटाफट से मेरे लिए. तो आई एम गिविंग यू 3 मिनट्स. बता दो फटाफट क्या आंसर होना चाहिए. मोर देन 1 इज करेक्ट. ओके, ये गेट 2024 का क्वेश्चन है. आई वांट एवरीवन शुड डू एंड यू शुड गेट आंसर करेक्ट इन फर्स्ट अटेम्प्ट. Yes, Udhav, I'll just tell you, beta. I'll just tell you. Yeah, Karthik, I'll just tell you. You just try to solve this question first. Very simple. Okay, which one of the following sets is a possible set of support vector? MCQ question. Okay, not MSQ. This is MCQ question. Yeah, I think this is 2 mark या 1 mark question होगा शायद. This is I think 1 mark question, very simple. Option D, Vishal. Chalo, let's see beta, let's see everyone, please do this. Okay, Sidhu, it's D. Chalo, Newsbuster D. Let's see beta, let's see. I'll just give 1 more minute. I think this is 1 mark question, I guess. Chalo, dekhte hain. Okay, chaliye, let's see how to do this. Let's see how to do this. So he says that we have 6 data points. Okay, x1, y1, x2, y2 till x6, y6. Okay, and the labels are given. Here. Okay, the labels are given here. He says y1, y2, y5 belongs to label 1, y3, y4, y6 belongs to label -1. A hard margin SVM is trained on the above data set. अच्छा, a hard margin linear SVM. I hope अब आप यहाँ पर समझ पा रहे हैं. I hope now you are able to get this. What exactly this linear SVM is? Linear SVM मतलब SVM कहेगा मेरे को अनशन डेटा चाहिए ही नहीं. I hope you are getting this. What does this linear SVM means? वो कहेगा मेरे को अनशंट डेटा चाहिए ही नहीं. What that अनशंट means? अनशंट means he doesn't want non-linear data. मेरे को तरीके का कायदे का डेटा चाहिए. Okay, because then only he will be able to separate each and every point. I hope you are getting this, है ना? तो he says मेरे को अनशंट डेटा मांगता ही नहीं है. तो he says it is a linear SVM because data is linearly separable there. चलो, अब हार्ड मार्जिन SVM इसने बता दिया. अब हमारे पास टोटल 6 पॉइंट्स है. ओके, so we have a total of 6 points. X, Y. Okay, we have a total of 6 points, and yeah, X and Y, between X and Y I'll be making the graph. Now I'll just make each and every point, right? Firstly I'll make point 1, 2 and 5. I'll make point X1, 1, 2 and 5 because they belongs to class 1. So these points are okay, 1, 0. So I'll just firstly complete this graph. Okay, then we have 1, 2, 3, 4, 5. okay, और यहाँ पे -1, -2, यहाँ पे this is -1 and -2. चलो, अब I would make 1, 2 and 5. तो 1, 0, 0, 1. okay, तो yeah, I'll just draw this with red color. 1, 0, 0, 1. और कौन सा पॉइंट है? 1, 0, 0, 1 and 5th is 2, 2. okay, the point is 2, 2. so this is, these points belongs to class 1. okay, these points belongs to class 1. Now next points are x3, x4 and x6. they belongs to class -1. 0, -1, -1, 0. okay, 0, -1, -1, 0. I'll draw this with different color. yeah, 0, -1. okay, -1, 0. and the third 6th point is -2, -2. okay, this is the 6th point, -2, -2. so these are the 6 points. okay, these are the 6 points. अब ये क्या कह रहा है? आपसे पूछ रहा है, he is asking you, ये क्या बोल रहा है? he asks you which one of the following sets is a possible set of support vectors. which one of the following sets is a possible set of सपोर्ट वेक्टर्स. ओके, इनमें से कौन सा पॉसिबल सेट ऑफ सपोर्ट वेक्टर हो सकता है? अब आप मेरे को एक चीज बताओ. सी इन दीज क्वेश्चंस अगेन आई एम सेइंग यू, भैया सपोर्ट वेक्टर मशीन में गेट वाले क्वेश्चन दे रहे हैं वेयर यू हैव टू अज्यूम हाइपरप्लेन. आपने 25 में भी देखा, 24 में भी देखा. नाउ दे आर एक्चुअली गिविंग यू वेयर टू अज्यूम दी हाइपरप्लेन. कोई बात नहीं, कर लेते हैं यार, अपना क्या जा रहा है. तो हियर व्हाट यू कैन सी इज, आई होप आपको शायद दिख रहा होगा, दिस कुड बी दी हाइपरप्लेन. ओके, मेन हाइपरप्लेन. this could be the main hyperplane. I hope you are able to memorize, I hope you are able to understand. this could be the one of the possible hyperplanes. okay, चलो, अब अगर ये hyperplane है, अगर अब ये हाइपर प्लेन है तो ये कह रहा है इनमें से कौन सा हो सकता है पॉसिबल सेट ऑफ सपोर्ट वेक्टर्स, राइट। तो आप एक चीज ये देखो कि भाई ना तो ये वाला पॉइंट सपोर्ट वेक्टर हो सकता है एंड नीदर दिस पॉइंट कुड बी दी सपोर्ट वेक्टर। If this is the main hyperplane, neither this point nor this point could be the support vectors. तो मतलब what are these points? This is x6, okay, and x5, okay, x5 and x6. This point is x5 and this point is x6. तो जहां पर भी फिफ्थ एंड सिक्स्थ पॉइंट है जिस सेट में भी, तो देयर दे कांट मतलब they can't be the support vectors. Okay, so let us check the options. So we have this x5 here, option A is wrong. Okay, then we have x4 x5 again here, option B is wrong. We have x5 here, option C is wrong. Now in this option D, x1 x2 x3 x4, yes, this could be the possible case of support vectors. So this is how the support vectors could be, matlab this could be one of the support vector plane and this could be one of the support vector plane. Okay, so this I can just say that this is weight transpose into x plus b, that is equals to -1, and this I can say that weight transpose x plus b, that is equals to +1. So here only the thing is you should know what is the definition of support vector. बस आपको इतना पता होना चाहिए था. I think there is nothing big in this question. Okay, there is nothing much to see in this question. तो बस आंसर क्या हो जाएगा? आंसर would be D here. बोलो, I hope this makes sense, है ना? I hope this is clear. चलिए, तो note it down. I'll wait for a minute, note it down, and we have a single concept that is remaining. We'll do this. Okay, just one more concept, then you will be free. यस, अब आप पूछ रहे हैं कि यस कि विच मार्जिन वुड बी मोर. सी देखो, हार्ड अगर आप इफ यू जस्ट कंपेयर अ हार्ड मार्जिन सपोर्ट वेक्टर, ओके, इफ यू कंपेयर अ हार्ड मार्जिन along with soft margin, so that actually depends on the data set. Okay, if you compare both, no, that actually depends on the data set. कैसा data है आपके पास? Okay, तो if data is linearly separable, okay, if data is linearly separable, then that is a guarantee that जो hard margin और soft margin होगा, if mispredictions are more, तो that means soft margin, the margin would be less. Okay, margin is less. Okay, soft margin, sorry, ये hard margin में margin would be less. Okay, margin is less, और soft margin में margin would be more. Okay, margin is more. ओके, तो ट्राई टू अंडरस्टैंड द कॉन्सेप्ट. नो, वो बेसिकली देखो, हार्ड मार्जिन सेज कि मुझे एक भी मिस क्लासिफिकेशन नहीं चाहिए. आई डोंट वांट एनी ऑफ द मिस क्लासिफिकेशन. तो क्या करेगा? ही वुड ट्राई टू मिनिमाइज, कितना भी तुम मिनिमाइज कर दो मेरे को कोई दिक्कत नहीं है, बट ही डजंट वांट मिस क्लासिफिकेशंस. तो वहां पर डेटा को मगअप करने लगेगा, है ना? तो मतलब वो सारे प्रॉब्लम्स आ जाएंगी देयर. बट सॉफ्ट मार्जिन सेज कि ठीक है यार, अनशन डेटा को मैं क्या ध्यान ही नहीं दूंगा. आई जस्ट वोंट बी वेस्टिंग माई टाइम ऑन दैट नॉन लीनियरली सेपरेबल डेटा. साला बेकार डेटा, मेरे को टाइम ही नहीं देना उसके लिए. तो व्हाट आई कैन डू इज आई कैन जस्ट एक्चुअली हैव सर्टेन मिस क्लासिफिकेशंस डिटेक्टेड बाय और डिटरमाइंड बाय दिस स्लैक वेरिएबल, और आप मार्जिन को तो बड़ा ही रखो, कोई दिक्कत नहीं है. जो तरीके का डेटा है उसके लिए तो वो मतलब इफ दैट अनसीन डेटा कम्स, तो एटलीस्ट दैट वुड बी करेक्टली प्रिडिक्टेड. तो इफ मार्जिन इज मैक्सिमाइज्ड फॉर अनशन डेटा, स्लैक वेरिएबल कह देगा भैया ये मिसप्रेडिक्शन है, अब मान लो तुम इसको. तो आई होप उद्धव दिस इज क्लियर, नो? Okay, but still it depends on the data. Still it depends, matlab this depends on the type of data. Okay, still I would say this depends on the type of data. कैसा data है? Okay, type of data and mispredictions. Okay, still it depends on the type of data and mispredictions. Okay, still it depends on the type of data and mispredictions. So we have to maximize margin. Hard margin also wants to maximize it, maximize the margin. Okay, hard margin SVM also maximize the margin, but he has a limitation. He says कि I won't be allowing any misclassification. अब वो margin घटे तो घटे, मेरे को मतलब नहीं है. But soft margin says कि भाई अगर अनशन डेटा आ रहा है ना, उसको slack variable कह देगा कि ठीक है यार ये तो wrongly classified है, but I would be maximizing it to my full extent. कि कर लो, maximize कर लो. अनशन डेटा को वो वैसे ही कह देगा ठीक है भैया ये जो है गलत हो गया आप हमसे प्रेडिक्ट. तो दिस इज द डिफरेंस, दिस इज द डिफरेंस बिटवीन दीज टू. ओके, ओके, चलिए अब यहां पर इसके बाद वन लास्ट कॉन्सेप्ट इज द कॉन्सेप्ट ऑफ कर्नल्स. ओके, वन लास्ट कॉन्सेप्ट इज द कॉन्सेप्ट ऑफ कर्नल्स. ओके, कर्नल ट्रिक. अब अगर मान लीजिए फॉर एग्जाम्पल इफ, ओके, जस्ट फॉर एन एग्जाम्पल इफ देर इज अ अनशंट डेटा विद मी. ओके, जस्ट फॉर एन एग्जाम्पल if there is a unshunt data with me, I'll just show you what exactly unshunt data is. ठीक है, अब देखो अब क्या होता है unshunt data. The data that is scattered on the bottommost plane. You just see here the data that is scattered on the bottommost plane. Okay, that is the unshunt data. मतलब that is non-linearly separable data. ये वाला डेटा. अब मुझे बताओ भैया ये वाला डेटा तुम क्या कभी भी कर सकते हो, इसको सेपरेट कर सकते हो एक प्लेन से? ऐसा कोई तुम्हें प्लेन ही नहीं मिलेगा. आई होप यू आर गेटिंग दिस. वी वुड नॉट फाइंड एनी प्लेन हियर दैट कैन एक्चुअली सेपरेट दिस डेटा. We would not find any plane here that can actually separate this data. I hope you are getting this. तो this is known as what? This is known as non-linear data. ठीक है, जिसको मैं तब से बोले जा रहा हूँ unshunt data. तो ये फालतू का डेटा है, मतलब है ना, मतलब फालतू का in the sense this is a non-linear data which cannot be separated by a hyperplane. Okay, तो for this type of data, what we do is, we use kernel trick. Okay, we use kernels. Okay, kernel is nothing. Kernel maps the point onto a higher dimensional space. Okay, so what exactly kernel is? Kernel maps the points onto a higher dimensional space. ठीक है, तो basically what kernels do? Kernel basically is a mapping function. वो कुछ नहीं करता, map कर देता है. अब जैसे for example this is the scattered data. Okay, that is non-linear. I hope you are getting this. This is the scattered data that is non-linear. So basically this is the mapping function. Phi of x equals to, here different mapping would be done for this x. अब जैसे मान लीजिए कि ये data है, I would just map it using some exponential function. I would just map it using some polynomial function. कुछ भी करके मुझे इस data को ऐसा बनाना है so that I can get a plane, using which I can separate the two classes. Just see the animation. Okay, just see the bottommost animation. Everything would be crystal clear now. Just see the bottommost animation. Everything would be crystal clear now. The data that is scattered on the bottommost plane. Just see the bottommost animation. क्या कह रहा है ये? The data that is scattered on the bottommost plane, वो हो गया non-linear data. अब क्या हो रहा है? We actually mapped the data on a higher dimensional space, जिससे कि मुझे क्या फायदा हुआ? I got this pink plane. जिससे कि मुझे क्या फायदा हुआ? I got that pink plane, and that pink plane actually is able to separate that non-linear data. Okay, that pink plane is actually able to separate that non-linear data. तो kernel is what? Kernel is a mapping function. अगर कभी भी कोई पूछे इंटरव्यू में कि how to approach a non-linear data if you want to train it using SVM, तो firstly you have to decide which kernel you have to use. Okay, firstly you have to decide which kernel you have to use, whether it would be which kernel you have to use. So we have number of types of kernels that a data scientist knows कि अगर ऐसा data है तो मेरे को ये kernel use करना है. If that is the data, that kernel is to be used. So this is basically see here, non-linear data, we mapped it onto a higher dimensional space using what? Using a mapping function. There I found that yes, I have a pink plane. I have a pink plane that can actually separate the data. बस यही होता है कर्नल ट्रिक और कुछ भी नहीं है. दिस इज ओनली कर्नल ट्रिक. ओके, एंड these are the types of kernels that you have to learn. These are the types of kernels that you have to learn. So first one is polynomial kernel. I'll just show it here. Okay, I'll just show it here. Yeah, this is the polynomial kernel and this is the mapping function that is given. Okay, polynomial kernel, ये mapping function given है. Then Gaussian kernel, this is actually a general purpose kernel used when there is no prior knowledge about the data. That is actually one of the general purpose kernel that is used when we don't have any knowledge about the data, and this is the mapping function. Okay, this is Gaussian radial wise kernel, RBF, very important. Again, there is no prior knowledge and this is the mapping function. Laplace RBF kernel, no prior knowledge and this is the mapping function. Hyperbolic, ये neural network में use होता है. This is highly used in neural networks. तो number of times we have to try it. Okay, मतलब there is no pet rule. There is no pet rule कि यही वाला काम आ जाएगा. We have to try it number of times. Sigmoid kernel, again for neural network, and this is the mapping function. Similarly, Bessel, ANOVA, linear splines. Do not learn this. I would say just do not learn it. Okay, just do not by heart it. But yes, the thing is that you should know what exactly kernel is. Okay, हाँ, ये mapping function है. Yeah, this is mapping function. Newsbuster, correct. Your thinking is correct. Okay, तो this is a kernel function. है ना? तो ये आपको याद नहीं करना है, but ठीक है, you should memorize. Okay, you should memorize. No, you don't have to mug up. Okay. चलिए, तो आई थिंक दिस इज ऑल फॉर सपोर्ट वेक्टर मशीन. ठीक है, दिस इज ऑल फॉर सपोर्ट वेक्टर मशीन and I'll upload the PDFs. Okay, and just try to revise the concepts that which you have studied. Okay, and for more questions I think you should either search online, or if you could join Agni Pariksha batch. We have number of batches. No, there actually we give you these questions, है ना? तो वहाँ पर yeah we give you these questions. Okay, तो this is how I'll end support vector machine today. ठीक है? Okay, this is how I'll end support vector machine. Okay, chalo, thank you so much beta, thank you so much for your cooperation. Yes, Newsbuster, I'll just take certain PYQ sessions. Yeah, that is for sure. Okay, I'll just take PYQ sessions, that is for sure. Okay, so but that would be sometime after, in the month of December, no, that I would take for sure.